I don't know where it is, otherwise I would have snooped it already. There was a time where I was trying to gather some budget together to try and get it funded through the BA. So.
He's been doing all of that. Mainly because it keeps working.
Yeah, he does tend to just fixate and go mad. So let him. Just
sort himself on that and just focus.
Yeah.
Tu présentes ton matin, vas-y. Tu présentes?
Aujourd'hui?
Yeah.
Ouais, j'ai une session.
What are you doing, Freddy Fox?
Demain, c'est quoi ton sujet?
Faire la...
Yeah.
Yeah.
Hello, everybody, and welcome to BSV DevCon. I am Brett Banfi, your host, Manifestival, and I am pleased, privileged, and thrilled to be here, your host for this event. Over the course of the next 3 days, you are going to hear some wonderful, amazing information about the network, about its high scalability, millions of transactions per second, its SPV from Section 8 of the white paper, enabling peer-to-peer transactions and overlay services. But in addition to these wonderful features of the network, it's also important that we look at the way in which we're able to interface with that network. And so that's why, for our first presentation, we have Thomas Giacomo and Darren Kellenschweller, who will be presenting at a high level on the way in which those tools, the services, the support, and the infrastructure of the network can be empowered by developers. Thomas.
I keep my name. Hello. Hello, hello, hello. Hello, hello, hello. Hello, hello, hello. Hello. Ah, yeah.
That's what she said.
Good morning, everyone. So I'm going to start with providing new developers on BSV an high-level overview about what is BSV Blockchain, what are the capabilities, and what kind of developer tools you can use to build on the BSV Blockchain. I'm going to start to try to explain what is BSV Blockchain. So high-level BSV Blockchain is a UTXO proof-of-work layer 1 blockchain platform built on the Bitcoin protocol. It's one, we're going to cover the different capabilities of BSV, but thanks to these capabilities, BSV is one of the fastest, cheapest, and most secure blockchain on Earth to enable applications to build real-world solutions for real-world problems. As you can see on the right-hand side on the slide, we have what we're going to announce today. We have a Mandala network allowing BSV to have some permission or private capabilities on a permissionless blockchain. What you can do on BSV, you can create some tokens, some smart contracts. You have also some data on-chain capabilities. And what makes BSV different is really peer-to-peer communications at the edge of the networks, thanks to the SPV capabilities, so the Section 8 of the white paper. All these capabilities will be covered today in details by the different speakers. So I will jump to the next slide. As I mentioned earlier, BSV is the cheapest, fastest, and most secure blockchain on Earth. That's what makes BSV different to the other chains. And in addition to these technical capabilities, BSV is also regulatory compliant. We cannot reach adoption of the DLT technology without a regulatory compliant framework. That's one of the most important topics that we would like to highlight today. We're going to cover exactly why BSV is regulatory compliant. In terms of scalability, we are currently testing the core of the network with a new update of the node software called Terranode at 1 million transactions per second with 6 nodes. The detailed presentation of Terranode will be done today by Sigi. So that's at the center of the network. We have a very capable node software, and on top of which you can have all the flexibility of some layer 2 capabilities at a layer 1 level, or some permission blockchain on a permissionless blockchain. That will be covered also today when we're going to announce the Mandala upgrade of BSV blockchain. BSV is also one of the most secure, if not the most secure blockchain, thanks first to its consensus mechanism. The proof of work is the most secure consensus mechanism, but also because the rules of the network are set in stone. Right? We apply strictly the Bitcoin white paper, and because we don't change the rule, the application don't have to update their application as soon as one minority of developers want to change the rule, right? So that's what also makes BSV different, is that the rules of the network apply strictly the Bitcoin white paper, and they are set in stone, right? That's also an important topic to mention. We are indeed a layer 1 blockchain, so on BSV you don't have any additional layers. Everything is at a layer 1 layer, but what we aim to release also this year through the overlay network is to provide the ability to have a certain flexibility to build your own independent environment within a layer 1 blockchain. So you can imagine that if you are a central bank and you want to create an overlay network just to deal with your Swiss franc CBDC or pound CBDC, the central banks of England would be able to create a dedicated overlay network only dealing with the digital pound transactions. That's what makes BSV flexible, aligned with business requirements, and without compromising the security of the network. Everything, again, will be covered today. BSV is also regulatory compliant. First, BSV is considered as a commodity because the rules of the network are set in stone. We can easily pass the OE test. The OE test is if a minority of stakeholders has the ability to change to make profit, then the underlying asset is considered as a security. And because the rules of the network, called network access rules, are fixed, BSV is not a security. So that's a really important topic. If you really want to have adoption of the blockchain, we want to make sure that the underlying technology is regulatory compliant. What we also are releasing is a digital asset recovery mechanism, allowing to retrieve your digital assets if you receive a court order. So that's also a very important topic, as we want the technology to be legally binding and to make sure that the technology is aligned with existing law system, and it's not a parallel system. In terms of cost, you can find very low transaction fees. The reason behind that is that miners in the ecosystem are indeed incentivized to shift their business model from a block reward business model to a transaction fees business model. And as you can have as many transactions in each block, thanks to the volume, miners would be able to have a certain amount of revenues. On BSV blockchain, the transaction fees are very low. We are talking about 1 sat per kilobyte, which makes BSV blockchain the cheapest blockchain on Earth. This is a very important topic to consider, because when you are an application, a large corporation, or even a startup, you want to decide which blockchain you would like to use. The main criteria that you're going to identify are the cost, the speed, and the security, right? So that's why we would like also to emphasize the fact that in terms of cost, BSV is the cheapest blockchain on Earth. This is a high-level overview about our ecosystem. So this is the Gartner Web3 mapping, referencing the different Web3 ecosystems. So we try now to be aligned with existing industry standards to make sure that BSV also will be recognized as a major blockchain ecosystem. So as you can see, if you are a new developer, you have plenty of tools to use. You have some pre-deployment, post-deployment services, and in this square here, you can find the different applications. You have also some token, vast majority of token protocols, smart contract solutions, but also some blockchain explorer. You are also able to request some funding. We have VC funds very active in the blockchain, in the BSV ecosystem as well. So our goal is to make sure that as the association, we encourage different stakeholders to participate to our ecosystem and to make sure that we would build the most important Web3 ecosystem on the BSV blockchain. In terms of industries and vertical, we have more than 160 applications on BSV in different verticals and sectors. We are really encouraging different applications to solve real-world problems using the technology and not the other way around. At the end, the technology is just an enabler to improve process efficiency or to reduce cost in the real world, right? So that's a very important topics that at the end, we need to solve real-world problems using the technology and not the other way around. I'm going to cover some elements about the association, so BSV association, and our roadmap. So the association is the open source body of the ecosystem, meaning that we are what the Linux Foundation is for the operating systems. We build open source components so that application can use and build on top of the technology, right? That's what we do, and that's what we are. As the open source body of the ecosystem, our first remit is to be the steward of the protocol, make sure that the rules are applied and are fixed, allowing businesses to trust the network, right? If the rules are not fixed, then businesses won't be able to trust the network because everyone can change the rules, right? So that's our first objective, is to make sure that we are the steward of the protocol and we make sure that the rules stays fixed, right? That's one of the most important objectives and topics for us. The second part is that we build open source tools on core infrastructure components, but also on developer tools. In terms of open source developer tools, so we are taking care of the development of the core node software called Terranode, but also overlay services, the SPV wallet reference implementation, and different BSV libraries in preferred programming languages. What we are doing this year, we're going to explain it later, we are transitioning the network to a new network topology called Mandala network, allowing applications to leverage the capabilities of Terranode. And in order for the entire ecosystem to do that, the association is developing the different reference implementations for the core node software, the overlay services, the SPV wallet at the edge of the network. We are also clarifying our open source guidelines to encourage different developers to just contribute to core infrastructure components and to make sure that we are reaching what we call the flywheel effects, where developer will just be able to improve the different open source components. Instead, in terms of standard governance, we are establishing some BSV standards to allow a certain interoperability within the ecosystem. We've released last year, and the Babbage team is quite involved in the BRC repository, so the community is welcome to contribute and to discuss any proposal of standard. And then the technical standard committee are picking some of these discussions and elevating it as an industry standard within the ecosystem. So that's our first objective in terms of standardization, but our second objective is also to align with international standards, such as IEEE, W3C, or ISO. For instance, if you take the example of the international payment system, we would like BSV to be aligned with the ISO 222 standard for international payments, but also for decentralized identity standard from W3C, for instance. So that's also an important topic. If we want the technology to be adopted, we also need to make sure that the technology is recognized by international standards. and in addition to set up some internal BSV standards as well. In terms of education and research, the education team of the association is doing a great job to provide online courses welcoming tech and business profiles on BSV, allowing builders to build on top of BSV. That's one of the objectives of the education team. We are also partnering with major academic partners to create some research program, allowing our different members to benefit from the research program if they are members of the association. We are also providing some blockchain lectures and creating some blockchain certificates in collaboration with academic institutions. And last but not least, public affairs. We are quite active in discussing with different policymakers, financial regulators, to ensure that the technology is well understood and to ensure that the different applications building on the BSV blockchain will be able to benefit from a regulatory compliant framework. So that's our role as the association. We act as a neutral entity within the ecosystem, allowing different applications to build, right? That's our main objective. In terms of our roadmap of the year, this is our roadmap of the year. You can find it also on our website. We try to update the website quite frequently. Of course, it's a live roadmap, so some of the components might change. But basically, what we're going to release this year is the Mandala network with Terranode, overlay services, SPV wallet. These three components will constitute the new network topology, allowing application builders to be able to leverage the capabilities of Terranode, right? Terranode will be only for miners, so then application builders should be able to interact with Terranode through the SPV wallet and overlay services. Everything will be explained in more detail today, but that's the main objective of the year, is to first release Terranode in Q4, and then on the overlay side, you have different subcomponents. Basically, we're going to release the first overlay reference implementation in August. Terranode will be released in Q4, and the SPV wallet is already live in public beta, right? So these three components will constitute the new network topology, allowing application builders to leverage the capabilities of Terranode. In terms of protocol stewardship, we released the network access rules. The network access rules are one of the most important topics for the ecosystem because they protect the ecosystem against centralization, right? Centralization is a concentration of power through a minority of stakeholders. If the rules are fixed, it doesn't matter how much stakeholders are part of the ecosystem because no one can change the rules, right? So the network access rules are here to protect the ecosystem against centralization and ensure that BSV is decentralized. The protocol restoration will be done by the end of the year. One example of the protocol restoration will be the restoration of the obver opcodes, allowing to have specialized transaction dedicated to different use cases, leveraging also the capabilities of overlay services that we're going to cover it later on today. And then in terms of marketing education, this year will be a major reshape of the website. One of our goals is to improve the developer user experience. We were not able to do it before because we need to reshape first the network to then adapt the documentation. So that's why the current developer experience is not the best one. We are aware of it, but we need first to develop the new network topology and then adapt the documentation. So that's something that we're going to do this year. In terms of events, the growth team organized some hackathon in San Francisco, I think, which just ended last week or 2 weeks ago. And obviously, the LBC and the DevCon are one of the main events of the year. And in terms of educational program, we are partnering with different academic institutions. For instance, we just closed a partnership with University of Zurich, for instance, to set up some set up some research program, but also to have some blockchain certifications, allowing students to discover BSV and to learn more about the technology. So that's the goal of this year. As you can see, there is a lot to do, and we are not doing everything on our own. We also want to leverage the skill sets of different teams of the ecosystem. That's what we are doing with different teams, Project Babbage, for instance, on overlay services, but also Gorilla Pool on the Go libraries, sCrypt with the Python libraries, and Tal with Arc, and Chain are also part of different open source components. So the goal is really to clarify the open source governance, to leverage the skill set of the ecosystem, and to build the best technology. And finally, that will be on my last slide before Darren will jump into the different developer tools. These are our main objectives of the year. The main objective is to release a blockchain, a layer 1 blockchain at 1 million transactions per second. That's the main objective of the year. Again, you can check the Terranode Explorer. We are currently testing the Terranode software with 6 nodes at 1 million transactions per second. So we trust that we're going to be able to release a layer 1 blockchain at that scale, but obviously Terranode will be only used by miners, so we have to make sure that other infrastructure components will be also adapted to this kind of scalabilities. In terms of open source tooling, that was one of the main objectives of the year, to really clarify our open source guidelines, to encourage developers of the ecosystem to participate and to help us build main open source components. So that's something that we clarify on the Bitcoin SV GitHub repository. You can have a look on the TypeScript library, and on the TypeScript library handled by Project Babbage, you will be able to see the different open source guidelines to contribute to core open source components. Education and research, same here. The goal is not only to provide online courses, the goal is to leverage existing established academic institutions to share our blockchain knowledge, technical but also business, in existing academic institutions. We don't want to invent the wheel. There are many academic institutions that we can leverage to disseminate the BSV knowledge and to make sure that the students or the professionals will be able to leverage the blockchain capabilities to implement the technology within their business. In terms of developer experience, I mentioned it a little bit earlier. We're going to reshape our overall developer experience with a new documentation, with a new website as well. That will be during the year. As I mentioned, everything is connected, so obviously, we first need to reshape the network before updating the documentation. So please don't hesitate to let us know what are your different needs. You can reach out to us on Discord if you also want to participate to this exercise, because what we want is to make sure that we provide the best documentation for experienced developers, but also for new developers. And in terms of standardization framework, as I mentioned, last year we released the BRC. It worked quite well. Now the ecosystem is able to discuss a proposal of standard that then the technical standard committee would pick and elevate it as a standard. So please go to our GitHub repository, discuss with the community on new standard proposal to make sure that we would be able to implement them into reference implementation, such as the overlay services reference implementation, but also Terranode and SPV wallet. And the last topic is a system integrator program that will be discussed this year but launched next year to really make sure that if you are a builder on BSV, you can get certified to ensure that your technical components are aligned with the way you should build on BSV. It was a need coming from the ecosystem in a sense that we identified that a lot of applications were not using BSV the correct way. So later on next year, you will be able to make sure that you can get certified by the association, but later on by different consulting firms. You can imagine that in the coming years, you can have firms such as Deloitte or Ernst & Young consider as system integration partner of BSV, and then they will be able to certify that, yes, you built your application the right way. So that's our goals of the year as the association. So please reach out to us during the London Blockchain Conference if you want also to participate to some of these open source components. You can come to us and we can discuss that. The goal will be to make sure that the talents that we have within the ecosystem allows us to build the best technology and to leverage the different developer skill sets. I'm going to hand it over to Darren now. Darren will cover in depth the different BSV developer tools that you, as a new developer, can use to build application on BSV. Thank you.
Thanks, Thomas. Thank you, Thomas. Making sure I have my mic on the right mode. Everyone hear me okay? Great. So largely, we were thinking about the BSV developer's journey. I mean, really, largely, it's application development in general. So a lot of the tools that you'll be using, of course, are just frameworks, Web 2 stuff, databases, all of the stuff that application developers normally develop with. So what do we mean by the developer journey for BSV developers specifically? A lot of the time, it's about transaction template creation. Perhaps you're developing some specific predicate for a specific use case. So you need the tools to write your own smart contracts, or maybe going lower level, writing opcodes, novel locking scripts, and being able to test whether you can unlock them in certain scenarios. So you need things like the core libraries, the script interpreters. You need to be able to test those unlocking functions, of course, and so on and so forth. So a lot of the new stuff that we see in future is to do with SPV, so doing all of that on a local machine rather than throwing transactions onto testnet. We see a lot of people just testing locally, testing on their own reg test, and making sure that those transactions make sense before broadcasting them whatsoever. But of course, there is the use case of using explorers, using testnet, and using that type of API as well. So in terms of where the pain points here, we did consult with probably a lot of you, but otherwise just generally developers in the ecosystem. And this is what we got back, that really smart contracts, and thanks Xiaohui and the team at sCrypt, pretty much that or good, and some of the things being I don't use it, and probably because it's so bad that you don't use it. So significant improvements could be made, and this was a couple of months ago. So one of the biggest things that came up was core libraries, perhaps on the education front of transaction templates and maybe how you would use sig hash flags, not particularly well understood. Not enough languages are supported in terms of the various different ecosystems. And token protocol specific tools. So missing a standard process for how you tokenize things. There's lots of competing examples, but nothing generic. And on the right here, lack of understanding in educational material on how overlay networks can come into fruition. So top 5 priorities, you can see this is more than 5. So one of the top things was core libraries that came up, and we've been working on that since. So what's wrong with core libraries? Lack of maintenance mostly, lack of consistency across the different repositories, different philosophies, different approaches to the code. And so we've addressed that more recently with the standardization of the TypeScript SDK. So thanks to shout out again to the Project Babbage team for developing that along with us. Shout out to Luke and Gorillpool with the Golang SDK. We're working on that. And Xiaohui and the team at sCrypt in Python as well. So those are coming along nicely and will be released in the coming months. So token protocol specific tools. Tokenize do a fantastic job. There are a couple other protocols that sort of came and went. Of course, ordinals being the most popular at the moment, some really good work being done there. Nothing to do with us, although we support this sort of development, obviously. There's a lot of abandoned protocols as well, and so over the last couple of years, things that came and went, different approaches that were maybe popular for a while and then sort of fizzled out. So the solution being some analysis. I mean, nChain did some analysis of the ecosystem and the various different protocols for tokens, but I think probably just a different philosophy that we can probably clarify in terms of so that there is a unified approach to what we consider to be a token in the first place. So the educational material is probably where we need to do the most work there. But the other thing we're working on is example overlay implementations, and the idea being that we could develop those into overlays that are specific for handling particular type of tokens in the ecosystem. So that might be one way we can improve there. In terms of improving the embedded wallets, for example, there's sort of a different approach when it comes to the vast popularity of things like MetaMask. And account-based blockchains have a very sort of, well, browser wallets are very popular, and the idea being that perhaps you need a slightly different approach for BSV, specifically with SPV, where you're doing all the validation on your own machine prior to broadcast, but you're not necessarily reliant on third-party services in the same exact way. So there's improvements to be had there, I think, in terms of, yeah, for example, attempting to send transactions from one browser on a laptop to another browser on a laptop somehow, perhaps in the same way that we always communicate day to day over these video calls. And there's all sorts of NAT that goes on to get video linked between us. Why can't we do that for transactions? So we're doing more of a P2P route for transactions. So that's the sort of direction we're heading on the embedded wallet side. So let's see, smart contract solutions. I think, yeah, this is maybe a lack of diversity would be the only criticism there. sCrypt just dominates that entire space. There are other approaches. I know with my work in ELAS in previous years, there's different approaches, different high-level languages that you can use to develop that sort of thing, short codes for segments of opcodes that do specific things. And I know nChain have all sorts of technology that they're working on that perhaps we'll talk about later today or over the week. So there's lots of diversity to be had for different approaches to that same topic of trying to have a higher level of understanding of what these predicates are doing, not just for one transaction, but sort of over a course of state transitions, for example. And obviously a worthy mention, block explorers. So I have somewhat of a deprecating view of this in terms of I think that it's quite expensive to operate without corresponding revenue stream. And I think that we can probably do better there in terms of not getting the entire industry to rely on something that is sort of pretend free. So at the moment, you can get transactions from all history absolutely for free. And as much as that's doable at our transaction rate now, if we imagine a world in Terranode where there's 1 million transactions per second one day, that gets extremely expensive to be able to facilitate that. So understanding where we might need to go in terms of facilitating that economically is something where we can improve in terms of the developer tools. So making sure there's SPV solutions to that problem. So something like an overlay where you're pushing transactions onto this service because you need it back at some point, and you're paying a corresponding fee for that service. So yes. So there's no technology platform that has been successful without the strong, large developer ecosystem. That's certainly true. So part of the work that Marcin, there he is, Marcin Żytecki has been doing is considering a soft landing approach in terms of understanding really where these developers are happening. Someone's making hand signals to me. In terms of, there we go, I think that's what you meant. Yeah, great. So in terms of making sure that we're understanding where people are coming from, whether they're blockchain developers from Ethereum or other blockchains, or whether they are BSV people already, and we're just trying to get them to shift mindset in terms of the Mandela upgrade, considering the network topology is going to be slightly different post-Terranode, different approach, considering the scalability, because even veterans that have been doing it for 15 years might need to take a slightly different approach long-term to consider how that might change in future. And of course, people who are just regular developers with no blockchain-specific experience, there's different routes that you would need to go. Oh, your section. I didn't realize this is your section. I'm just stealing you. So Marcin, coming up. That's what the hand signal was.
Thank you. So my name is Marcin Żetecki. I'm technical outreach specialist in BSV Association. Thank you, Darren, for my presentation. So there is no technology platform that has been successful without a strong and big developer ecosystem. And right now we have 400 developers, active developers. What does that mean? That means they're updating repository 10 times per month. So we know that we need much more developer in the next few quarters. That's why we start thinking about developers onboarding, the new developers onboarding on BSV blockchain. So we say that it's the fresh blood. And today it will be a very quick overview about the developers relationship program. So if you have more questions, if you want to go deeper, you can ask me during this today or tomorrow at the London Blockchain Conference. So we have 4 different pillars here: the soft landing, mentorship, advisory, financial support, and exclusive beta access. So let's start from the first one. So as a new developer in each ecosystem, you are the fresh. So we can say that you are the junior. And we try to onboarding the aspiring developers on BSV blockchain. So we try to help them to understand what the UTXO is. We are the guide for the new developers. We help you to understand how to step-by-step understand what the BSV blockchain is. And also at the end, we redirect you to the developer space, which is working right now by Thomas, utilization team by Thomas department. It will be the one place where you can find all information like libraries, developers tools, like documentation, like everything in the one place. So after that, we can say that you are the onboarded on BSV blockchain, and we can say you are the junior in our ecosystem. So this is the first step for you. Then the second step is, after that, in each ecosystem you try to, or you are the Java developer, or you are C# developer, Python developer, you are from the junior, you go to the regular developer. So you try to learn much more about each ecosystem. So you suppose that you go to the workshops, you can go to the hackathon, you can learn much more about BSV blockchain, but also you can share the knowledge with the others. So you can also help the other people to understand what the BSV blockchain exactly is. And maybe you start to develop some proof of concept project. Maybe then we have offer for you that the business mentorship and tech mentorship. So if you have the proof of concept and you want to learn much more about BSV, then we can help you from the technical point of view to go deeper in BSV technology. If we are talking about the business mentorship, we're thinking start cooperating with Block Dojo, which is Matthias will presenting the Block Dojo after my presentation. So we try to help and increase or growing your proof of concept, your idea in our ecosystem. And after that, we can say that you are the regular developer. So you know our libraries, you know our tools, you know SP Wallet, you know sCrypt, tokenize, everything. But you also use our tools. You are almost active developer like senior developer. So maybe you want to build some MVP project. Maybe you have an idea of some startups like tokenize, I don't know, Big Ben, or you want to build the second Uber using the BSV blockchain as a fuse for the transaction. Then we have the different grants, financial support for you. So the first one is the technical grant. So if you figure out some idea and you see that we don't have any libraries or tools which you need, we can recognize these tools and we can help you to develop this tool in our ecosystem, which is also available for BSV Blockchain. And outsourcing developments, that means we have trusted developer, trusted vendors in BSV ecosystem like Fortran, like Babbage, like Gorilla Pool, and then we are looking for much more trusted developers, trusted vendors in our BSV ecosystem and back bounties. So after this step, we would say that you will be the senior developer or you will be our veteran in BSV ecosystem. So you know our libraries, tools, everything, you are using it, and you are developing an application, you're promoting BSV blockchain, and then you can be our trusted vendor, as I mentioned before, and you can join to develop our open source tools, our open source libraries, and then we would say that you will be the active developer in BSV ecosystem. That's why we want to increase this number from 400 to much more in the next few quarters. So this is all from my side today. It was 5 minutes, I think. And if you have any more questions regarding the Developers Relationship Program, so you can contact with me directly or during this DevCon day today or tomorrow on the London Blockchain Conference. Thank you, and I give stage to the Matthias.
All right, good morning everyone. My name is Matthias de Kneert Hope, and I am the UK Program Director for Block Dojo. If my next slide will come up, that will be wonderful. There you go. If you want to remember my name, it's a challenge, but give it a go. We're a global blockchain incubator, so we are based here in London, but we also have Filipino offices. And we provide a 12-week incubator program. But in order to show and illustrate to understand what we are actually doing, I think the best way to do is this. I'd like to divulge a little secret with you all. Marcin earlier mentioned developing the second Uber. Well, I invented the first one. I feel some skepticism in the room, but let me assure you, it's true. I was 21 years old. I was with some friends at a pub, and we invented a ride-sharing app. We were very excited. We wrote our business plan down on a little napkin, cheersed each other, and congratulated upon the inevitable fortunes that were about to be bestowed upon us. And of course, surprise, surprise, the next day, we absolutely did nothing about it. This is why we developed Block Dojo. It's a 12-week intense in-person incubator program aimed at early-stage developers, potentially technical people who have a great idea, who are excited to go build, but they don't really know where to get started. I want to avoid that they basically have the same problem as I did when I was 21 years old. What sets us apart from other programs is we're intense and in person. So we're unapologetically not remote. Because we believe if you put a lot of brilliant people together in a room for 3 months, it's really amazing what can happen. There we go. It isn't exactly our first rodeo. We've incubated actually over 60 companies already at this point, but we couldn't fit them all on this slide. So yeah, there's quite a few already successful people, and we want to build the ecosystem because we all know that the technology developing is great, but we also need to have businesses that actually use this technology to move things forward. Having a look at what our program is built up of, it's 3 main parts. I think probably most people will already be familiar with the MVP part, the minimum viable product. There's a lot of technical people in the room, so you will have a natural inclination to start building things, right? And we will do that in like the second part, where we do your MVP building in tandem with your financial model. But a big mistake a lot of people make in Web 3 and in Web 2 is they build something only to find out then that actually nobody really wanted it. So to avoid that, we start with our MVC stage. Anybody knows what MVC stands for? Close, close, close. Minimum viable customer. Well done. We invented ourselves, so well done that you know that. Basically what we're trying to do is make sure that whatever your value proposition is, whatever your problem is, that is actually something that people will want, and so you avoid spending time and energy on building something that then will go nowhere. After we build your MVP, building your MVP together, we will go into the MVS stage. Anyone know what MVS is? Want to give it a go? Minimum viable story. Because obviously we are here to like get you funded. You will need money to go develop, right? So we will take your value proposition and your MVP and we will craft it into a nice story that will attract investors and get you funded. So this is a rough overview of the program. And we believe that, if the next slide comes up, MVC plus MVP plus MVS means money. You will get your funding and you will be able to get your project off the ground. And we've done a pretty good job at it, actually. I'll go back here. We've actually done a pretty good job. No, not yet. Yeah. Because we are responsible for 33% of all UK blockchain funding. So if you're interested in, if you have an idea, you're an early stage entrepreneur and you don't know where to get started, just come talk to me. We actually have our cohort here as well. Maybe put your hands up, people from the Brook Dojo. There they are. They are building amazing projects right now using BSV Blockchain. So maybe have a chat with them over lunch if you think you can help them out. If you are yourself an aspiring entrepreneur, come and have a chat with me and maybe we can go build the next big thing on BSV. Thank you very much.
Check. All right. Next up, we have Michal Shinkech from sCrypt. Michal, take it away.
So does the micro work? Okay. So yeah, I'm Michael Schinketz. I'm a software developer at sCrypt. So apart from being the company's name, sCrypt, our main flagship product is a smart contracting programming language. And the language is based on TypeScript, so it's an embedded language. So it works just like in a regular node interpreter. So, and it compiles down to Bitcoin script. And it makes it really easy for developers to write smart contracts for Bitcoin without delving into like, you know, the lower layers such as opcodes and stuff like that. And apart from that, yeah, we also offer a whole suite of other software around that to make it easier to deploy these smart contracts and interact with them and on-chain. And yeah, that's pretty much it. That's the overview. So yeah, maybe if we wait for the slides, I have to actually show you some examples. Yeah. Yeah, so a smart contract is essentially a program that's embedded into a Bitcoin transaction, and it defines the rules of how funds transact on the chain. So for example, you can also think of a regular Bitcoin payment as also like a sort of a mini smart contract in that it checks the validity of a signature, simple as. But the Bitcoin has actually a language built in, so you can build more intricate programs with that. So in addition to, for example, checking a signature, you could do a whole bunch of other stuff. But the problem is that the language is defined in sort of machine code, and it's hard to write a more complex program, and that's where we come in. So we have a high-level language, which is really easily readable for developers, and it makes their approach a whole bunch easier. Oh yeah, yeah, something happening. Okay, yeah, that's it. Does it work? Okay. Yeah, so again, to repeat what I just said, so sCrypt, our flagship product, is also sCrypt the language, which is an embedded domain-specific language. It's built into TypeScript. So what is an embedded language? It's sort of just like regular TypeScript, but with some additional caveats. But it works, it interacts seamlessly with other TypeScript codes. So yeah, it's pretty easy for new developers to onboard because TypeScript or JavaScript in general is one of the most popular languages out there. Most of developers have at least once written in their lifetime some JavaScript code. Most of them will say it's not their favorite language, but everyone knows it. So, and in addition to that, TypeScript brings in type safety, which is comes in useful in like financial programming, because you want to define your programs more type safely, so you want to avoid some conditions that you didn't plan for. And yeah, you don't need to learn any new language. So I mean, there are a couple of people around here that are in this space for a bit longer, and remember that we had sCrypt as like a separate language, but we transitioned to TypeScript only, so you don't have to learn anything new. You can, if you know TypeScript, you can just delve into it. Okay, so smart contracts and Bitcoin. Usually people don't associate the two. When you say smart contracts, most developers think of Ethereum, which has, it's sort of more native to it, but Bitcoin from its inception actually had the capability to do smart contracts, but people didn't explore that too much. So the difference between Bitcoin and Ethereum is Bitcoin is based on the UTXO model, and whereas Ethereum is an account model. So if you think about it, in Ethereum, smart contracts are their own like separate entity, which have their own address and everything. But in the UTXO, it sort of transitions from one output to another. So the smart contract's address changes during its lifetime, which makes it a bit different. But our abstractions with sCrypt make it very similar to Solidity, so there's not much mental overhead that you need to overcome to start developing with sCrypt. So to elaborate on what the UTXO model even is, so Bitcoin is made out of transactions. So these transactions have inputs and they have outputs. So the outputs, they contain the coins in addition to a little program, which is the smart contracts or the locking script. And this program defines the conditions which you need to provide the inputs for in order to unlock it. So for example, a simple Bitcoin payment requires you to pass in a public key and a signature, and the locking script checks if the signature is correct and if the public key is associated with the correct address, and if so, you can take the funds out of the output. So that's pretty much it for the UTXO model, pretty simple. To make maybe things simpler to understand, you can think of the locking script as a function f, and the unlocking script is within an input that references this output that you're trying to unlock, and it proves the inputs to this function. And the function checks if everything is correct, and if the function returns true, you can take the funds. Yeah, so here's like an illustration of that. So again, these are two transactions. So F is the locking script. So that's F is your smart contract, right? And the smart contract takes in some inputs. So that's the X, and F checks whether some conditions, depending on the implementation of these functions, and if it returns true, the transaction is valid and the funds move to the next output. And if not, this second transaction gets rejected by miners. Okay, so regular Bitcoin payments, they're also referred to in a more technical level as P2PKH, which is pay to public key hash. It just, you know, when you open up a regular Bitcoin wallet and you send to an address, you put in an address, it creates a P2PKH transaction, which is standard. It's like a small locking script, few opcodes. But as I said earlier, you can have much more expressive scripts. They can reach sizes of many kilobytes, of many thousands of opcoins, even millions in some cases. And it quickly becomes unmanageable for developers to do it without the help of any tooling, such as sCrypt. So how does sCrypt work? So it's a high-level language. It compiles down into this locking script. Again, this locking script is more like assembly, but sCrypt is a high-level language. So this is an example. I hope you can see it back there. It's sort of small, but it's just a regular TypeScript class. You extend from the smart contract interface, which you import from our package, sCrypt.es. And yeah, this smart contract, what it does is basically you pass it in two numbers, and it checks whether they sum up to a specific sum and whether the difference equals to some other number. And if you provide such it's a solution to two equations, you can take the funds. That's pretty simple. That's just an example as like an entry. Okay. So that's what it compiles down to, right? So, I mean, the more technical of you, it will probably say, you know, what's the big deal? You can maybe take 10 minutes to figure out what it does, and yeah, fair. But that's just a demo example. So what if you have something like this? So this is more. This is just a tiny part of a much bigger script. But yeah, try to figure out that one. Yeah, I wouldn't do it. Yeah. So yeah, that's where sCrypt helps a bunch. Yeah. Okay. So that's the same contract again. So how are they made up? So you have. So it's a class, right? The smart contract, and it has properties. So these are pieces of data that are stored within the locking script. And you have a constructor where you define these values. And then you have entry points to this smart contract. So these are called public methods. So this contract has only one, but you can also have many. And if you can provide the correct inputs for any of these public methods, you can take the fonts that are locked within this smart contract. So in this case, again, you pass in 2 numbers, 2 integers, and you check whether these add up to a certain number and whether the difference is equal to another number. And if so, the contract terminates, you take the fonts, and the fonts are yours. So again, yeah, so these are, again, properties and methods. So properties are pieces of data stored within the smart contract, and methods are entry points to this smart contracts, which you refer to from inputs that are trying to unlock this smart contract. Yeah, a really nice thing about this transition that we did to TypeScript is all methods behave equivalently on and off chain. So if you remember, this compiles down to Bitcoin script, right? And that one is hard to debug. So if you go back to this, it's sort of, you need some specialized tooling to even figure out what the hell is going on here. But the nice thing is you have TypeScript debuggers, you have even the omnipotent console log statement, which you can just put into a method and you can easily debug. So it makes life for developers like me a whole bunch easier, really. Yeah, okay. Yeah, let me go back. So okay, so these smart contracts are by default stateless, and what that means is when you, for example, call this public method successfully and it returns true, the contract terminates and you take the fonts. But in some cases, you might not want to do that. You might want the contract to live a certain lifespan and then terminate on specific conditions. A good example of that is, for example, if you have 2 players and they want to play a game of tic-tac-toe on chain, and you want to, you know, make one player makes one call and then the other one makes a call, and then when, you know, one player has a solution, the contract terminates that. And that's when you have this thing called stateful smart contracts. So yeah, so smart contracts can simulate state with script context. So this context, this is an example of a contract call, right? So you have the smart contract here in this output, and you call the smart contracts method in the next transaction, right? And during the execution of this script pair, so the locking script and the unlocking script, you have a bunch of data that you can refer to. And you can also put assertions of this data, on this data, right? And that's the things that are roughly, that are marked in red here. So you have access to this script, and you have access to pretty much all of the data in the subsequent unlocking transaction. And what that means is you can do fancy things, like you can, for example, enforce that the next output will contain the same smart contract instance, but with some different data. So that's how you do, for example, this example of a tic-tac-toe game. What you would do is you deploy a game of tic-tac-toe with empty fields, and one player would make a circle in the middle, for example, and then this locking script would automatically enforce itself in the next output, but with an updated field value of the tic-tac-toe board, right? And you would do this until this locking script itself checks whether there's like a winning move or something like that, and then that's when this propagation ends, and the winning player can take the funds, for example. So a really simple example of this contextual data and making assertions on that is, for example, a time lock example. So this smart contract, it has a property that is a timestamp, just a Unix timestamp. It's just an integer, but it can check the lock time, so the unlock time of the subsequent unlocking transaction, and it can put assertions to it. So this, what basically this does is I can deploy a smart contract, we'll lock some funds into it, and then say, for example, that it cannot be unlocked until the year 2026, for example, right? So I would set this mature time to 2026, and So every contract call that gets done to this unlock method will fail until this timestamp is met. So you cannot unlock it until 2026, right? So that's a really simple example, right? So another example is a counter. So this is, you just have a counter value. You set it to 0, for example, and all you can really do is you can increment this counter by putting in unlocking transaction, creating an unlocking transaction, and it just enforces itself in the next output with this incremented value, and it goes on forever. So once you lock funds into this counter example, they just stay there forever. And all you can do is really just implement this counter. But for example, many of you probably see this already. This could be, you know, you can put in some extra assertions, maybe like some game logic, and it becomes a game, right? Yeah, so yeah, again, when you would use stateful and when you would use stateless contracts, it really depends on what you're trying, what problem you're trying to solve. So in a game example, you would use like a stateful contract for like, it could also be used for like an auctioning app. So you keep track of the highest bidder of an auction and things like that. And stateless is more simpler, so you can use like simple transfers such as a pay-to-PKH or maybe, you know, like a multisig and things like that. So it really depends on your application. Okay, so here are some interesting use cases that actually use sCrypt in the background. So the biggest one is probably Token08. So they're a company that tries to tokenize financial instruments on the blockchain, on BSV. And under the hood, they use sCrypt smart contracts to keep track of data of some of these instruments. So yeah, we have a couple of people from them here. So, and another interesting example is Adeus. I'm not sure if there's anyone from Adeus here, probably not. So what they do is they use sCrypt to sort of as a last will contract. So you can tokenize your assets, and when you pass away, you can automatically inherit or pass on your assets to someone else. And this gets enforced by the blockchain, so it's a lot cheaper than setting up a trust fund or something like that, which is in most cases too expensive for people. And this can drastically lower the barriers for that. Yeah, another use case is HODL Locker. So I'm not sure if any of you have used this. It's sort of a messaging board. But the interesting thing is, so each message is under the hood is an sCrypt smart contract, and you can lock funds into this message, so the smart contract. And the more funds are locked into this message, the more attention it gets. So, for example, yeah, here's the number of how much Bitcoin is locked into a message, and the more it has, the higher it ranks on this entry page of the. So it's sort of useful mechanisms to, sort of guide attention or to get rid of spam, for example. So it's really cool. Yeah, another really interesting thing is tokens. So tokens can be used with in the combination of sCrypt smart contracts, which enables for some pretty interesting use cases. And probably the match made in heaven is one set ordinals. It's developed by David Case. I'm not sure where he is. Oh, there he is. Yeah. And the nice thing about one set ordinals is it doesn't really require you to put any constraints on the locking script. So that means you can use it with the conjunction of sCrypt, and you can put arbitrary condition of the transfer of not only Satoshis, which is the native currency of Bitcoin, but you can also do the same with tokens. So this example is a smart contract of an ordinal lock, which is just listing. So if you have a token and you want to put it up for sale, you can do this in a trustless manner. So it gets, if you have a willing buyer, the token gets atomically swapped without trusting anyone. No? Okay. Yeah. So apart from listings, sale listings, you can do a lot of other interesting things, such as other financial instruments that are based on tokens, such as limit orders, loans, bonds, futures, options, anything really that you can come up with. Okay, so yeah, so for any of you interested, head over to sCrypt.io. We have, there you can find documentation, a whole course that helps you delve deeper into sCrypt development, and you also have links to socials. So we mainly use Slack and Twitter to communicate with our users. So yeah, it's time to build. Yeah, and sort of separately, independently from sCrypt, we're also in a collaboration with the BSV Association. We're helping developing the Python BSV SDK. It's sort of, it's not quite ready, but we're like 80% there. So that's the link where you will be able to find it. And it also makes life easier for Bitcoin developers. So for example, you can, it's Python, and you can use like 6 or 7 lines to create like a payment transaction. You don't have to manually construct any transactions or anything like that. You can use it for multisig, for example. No, it's lagging again. Oh. Yeah, multisig, pretty simple, 10 lines. And you can even use, like, if you wanted to do what I described earlier, such as manually going through script, you can also do that because it has a built-in interpreter for script. And yeah, much more. It also has ECIS support. It supports deterministic wallets. It also has ARC support. Yeah, much more. So go check that out. Yeah, apart from that, I also want to mention that later this year in the US we'll also host DevCon, but the date is not determined yet, so keep an eye out for that. It will be probably announced on Twitter. So yeah, that's it. Thank you very much.
Thank you very much, Michal. And Michal mentioned our next presenter, David Case and Luke Rohanaz from OneSat Ordinals as a novel use case of sCrypt. We have their presentation next, and they will do an introduction and overview of OneSat Ordinals as well as a question and answer period. So if you would like to participate in the question and answer period, I'll have a microphone and be walking around the room. David Case.
Hello. You and I can share. So this is kind of off the cuff, but I figure many of you who have been involved developing the space already know kind of some of what OneSat Ordinals is, and so we're going to give an opportunity kind of for any questions or any opportunity, or basically any discussions we want to have here. But I do want to start off by just describing what an ordinal is, and that is simply a Satoshi. Which is the fundamental value element on Bitcoin. And OneSat Ordinals is, and Ordinals in general, is simply just a set of rules that says when I have one transaction and those Satoshis get spent to another transaction, I can track each one as a trackable entity. And that is all an ordinal is. But because of that, that gives us the ability to use it as a token. To say that, okay, this Satoshi has had some significant event in its history that has labeled it as a thing that we want to track. Whether that be someone wrote a file onto it, made an image file that they wrote on the blockchain that belonged on the output that contained that one Satoshi. Now that Satoshi contains that image. And so by simply applying rules of tracking from one transaction to another where that Satoshi has gone, we can do things like the person who owns that Satoshi owns everything that has happened to that Satoshi. And it allows us to make NFTs and to do all sorts of neat and cool stuff, some of which we've figured out and some of it we're still figuring out all the time.
Yeah, I'll add a little bit more to that. One thing I sort of to frame this a little bit, the way that most token protocols work is there's something in the script or in the transaction every time that's sort of identifying that particular token. What's really unique about ordinals in general was that this was a very passive approach. It actually was originally sort of envisioned on the BTC blockchain, where they have a lot of constraints. They don't have full scripting capabilities. They can't do a lot of these things. And so we sort of just saw that idea and implemented it on BSV. And what this lets us do is occupy those other parts of the transaction that are normally used up by sort of labeling these tokens. And we don't need a label. Instead, we just track the origin of that particular Satoshi, and we follow each transaction as it moves along. And that gives us this like passive tracking, but it also frees up the other space in the token to do things like add sCrypt contracts and add this all really cool stuff. So, you know, we started with just the base protocol. The first thing were just like NFTs, people, you know, cat pictures, stuff like this. And then we did a community mint style fungible token protocol called BSV 20. It's kind of sort of like gimmicky on BSV because it's so fast and cheap that you could sort of just mint all of these tokens out to yourself right away, so it kind of doesn't have the same impact as like BRC20 on BTC. But that was just the stepping stone. After that, we did BSV 21, which is like single issuer. You're the issuer. You know, issue an entire supply of a token to yourself, like is a typical situation. But the ability to put the extra smart contracts in there means that you can do all sorts of cool things, like lock to mint that you saw up there, where people have a extra script in there that basically, you know, restricts who is able to get issued what tokens. From there, there's another team that built on something else that David did, which was the OPNS stuff. Oh yeah, thank you. Yeah, which is like domain name registration this way. Without getting too much into that, but the next big thing was POW20. So POW20.io was the website that first kind of demonstrated this. It's like a sub-protocol of what we call BSV 21, kind of. And what that lets you do is really, really cool. If you remember the early days of Bitcoin, people used to mine Bitcoin on their laptops. They used to, you know, eventually that was like completely obsolete. It was impossible. Bigger machines would outcompete you, and you just wouldn't get any coin. You'd be spinning away and getting nothing. So now we're able to do, with smart contract, enforce proof of work for issuance of tokens on top of BSV. So now people are creating all of these different tokens, and then you actually have mining software that you run on whatever machine that is actually running proof of work, just like you would mine blocks, submitting the solution, and only if you found a solution do tokens get issued to you. So it's just a lot of fun. There's so many possibilities. It's very flexible, and there's just a lot still to be done.
Yeah, and I actually, I'm louder than you, it sounds like. One of the things that someone has come out with recently, which is a contract I help write, but it really goes to what they're just saying on the sCrypt side of how good of a marriage it is between sCrypt and ordinals, because kind of the whole ordinals thing gets out of the way completely of the script. So like 2 months ago, I worked on this contract with a couple friends, and essentially what we came up with was a completely contract-generated custom image NFT, which is made up of, I want to say, 10 different layers of images with transparent backgrounds all stacked on each other. So every time someone calls this contract, it spits out a token that's completely different from every other token, and it's the contract itself has generated by applying some deterministic math to figure out, okay, this time I'm spent, this layer is going to be the dude with the frog on his head, and then the next layer is going to have a blue shirt versus no shirt versus, like, the contract itself is actually building up and layering these images on the fly, so that when it spits out an ordinal, it's actually an SVG, which is a image format that has all these different layers, and each of the layers themselves are different ordinals. And so it spits out essentially an HTML page that's pointing to a bunch of other ordinals, but that one is unique. And so there's a lot of these kind of like taking this next step of stacking these things together and layering them together and coding them that just allows really, really fascinating future capabilities. And I think we're ready to open up for questions unless there's anything else you want to share, Luke. Hi, Ty.
All right. Check.
Right. So, does ordinals, like, scale?
Yes, but because everything is based about the history of this Satoshi, in order for you to be able to know what you have in your wallet or to know what a thing is, you do have to be able to crawl back that Satoshi's history back to at least the genesis of whatever activity is you care about. And so I can send you an ordinal that is a cute little picture of a frog, but unless you look at that transaction's inputs and their inputs all the way back to wherever that frog got stuck to that Satoshi, you just know that you have a Satoshi. So the provable chain, yes. I mean, if I minted this and I sold it to someone and it's been around, maybe it's been 100 places. So you do need 100 transactions and Merkle proofs associated with those, or at least with the farthest one up, to be able to validate that, yeah, I own the frog. But you don't need to validate the 3 billion transactions or whatever it is that's been on the blockchain. You need to validate those 100,000 or those 100 transactions.
This is a common theme too with a lot of things in Bitcoin. Work really well when it's early, when there's not a lot of traffic. When there's more, it's a lot harder. And yeah, this is just another one of these areas where specifically in a big block world, we have massive amounts of data coming through. You need to have this mandala network. You need to have this next sort of ring of indexers, aggregators. People are piecing together the stuff that Dave just described there to give those answers quickly to a wallet, that sort of a thing. So yes, it scales, but yes, there's pieces that are needed in between to make that happen at scale.
And just one other aspect on that. Like in the world where people are trading NFTs based on these, when I send you that NFT, I'm going to send you that 100 transaction history as well. And so it's not like, I mean, so maybe there's 50 kilobytes worth of data that goes along with the image. It's not like this is huge amounts of unmanageable things. It's actually quite manageable, but the state of everything does kind of grow as time goes on. You look like you have a follow-up, Ty. Okay.
Hi.
Hi.
You guys will have to give us the websites for all these. You mentioned pow20.io. What is that image generator? Or tell us the websites of your projects. Thanks. That one,
there's a service called BubbleMint. And I think pretty much all the generative things have minted out at this point. There might be, I don't know. It was really a proof of concept, and there might be other things that come on top of it. But so that's BubbleMint.io, which is also, there's I don't know, they've got like some largest mint in history that's gone out right now, some little pixel foxes that are also on that platform. Yeah, pow20.io was we were not actually, that was not affiliate, completely independent with us, but we've kind of taken up the mantle and run with that. That's a smart contract that as you submit proof of work, it spits out tokens. I mean, OneSat Market is now what we've had as this alpha OneSat ordinal site for a while. It is now onesat.market. So that's kind of the continuation of a year and a half's worth of work with onesatordinals.com.
Yeah, so what we're doing, onesatordinals.com was the original website that we had all this stuff on. It's a little janky at the moment. We started building the alpha site to replace it because a whole bunch of stuff changing in the ecosystem. But that's pretty much all done. What's happening now is onesat.market is going to be like the marketplace, the NFTs, all the minting, everything. And onesatordinals.com is going to become more of a community site, developer resources, information about other projects that are also using ordinals, since it's a much bigger ecosystem than just us.
Awesome, thanks.
And we will have stickers with that new domain if you want some. Way too many, so you can have them all.
Hi, my name is Ken Sato from Endpoint. I have one of answer for the scaling for the ordinals. I think at the end we're gonna when we go next level for the scaling, we're gonna have a lot. Right now it's like ordinals. We have only one indexers, and everybody just following the indexers. But in the future, it's like all wallets which have SPV capabilities. They're gonna have the indexers inside, and they're gonna do indexing all the NFT on their wallets.
Yeah, I'm actually specifically for one-set ordinals and yours wallet, formerly Panda Wallet. That's actually a project I'm going to be starting on in the next couple weeks, is doing just that, such that it will do the indexing of those things by itself, and it'll keep all the SPV information and communicate it in SPV as well.
Yeah, I think that's right.
You're on.
That's the right thing. Yeah, and then global indexer is gonna be there, of course, because sometimes we need to have disaster discoveries or some kind of a backup, and when like wallets communicates, they can send the ordinal with history of the transaction with SPV proof itself, and then they can do the P2P communication wallet by wallet through SPV, and then like indexers and global indexers can coexist, and I think it's all we need. I think, and that's kind of like overlay network as well, I guess.
Yeah, and I think like the last year has really been kind of rapidly following little ideas and throwing stuff at the wall and see what works out. And I feel like we've kind of entered this now. Year 2 is really about stabilizing and making sustainable and moving forward. And Brett, neither of us had a presentation, so we don't know the time. So anytime we're done, you tell us.
Question? Anyone else out there in the audience with a question? Okay, you'll be next.
Thanks, Brett. I got my Pixel Fox. Oh, actually, it says I have 0 still, so something. I don't know what's happening, but I'm on Bubble Mint right now. You can connect yours wallet. It seems like it will generate a random one. It's pretty cool. So my question is an admission that I haven't taken a look at the smart contract, and I'm kind of curious about how sCrypt handles the whole ORD part of the op-if ORD kind of stuff. How is that injected? Can you just do that with? Can you inject op codes at the front of smart contracts, or how's that part done?
Not really. They have written a fabulous library called sCrypt ORD. So it's actually kind of at time of deploy. You don't just deploy the contract; you inscribe the contract, which writes the contract, but also sticks the inscription at the beginning in a. I mean, the whole inscription envelope is it's no op, so it doesn't actually change the code at all. So their code actually is written to basically handle sticking that at the beginning, and then in your contract code, you write it a certain way that when it restates itself, it does that. It does what it needs to do to either stick that there or to remove that or whatever, depending on the context.
So it's handled by their library. You don't have to write something special in the smart contract that does that.
Well, like for the main Bubble Mint contract, I had to actually kind of go my own way because we were doing new stuff. So it's like it handles the very standard case well. And for anything, probably anyone who isn't one of us is doing, it's fine. But like as we're getting new functionalities, and so for instance on that one, it's probably going to go more technical than I need to. But on the BTC spec, they've actually defined a mechanism for collections and parent-child relationships between ordinals by inscribing a child in the same transaction where you spend the parent. And you need to put extra metadata in the child inscription that says, I'm a parent, this is my mom, or whatever. And so like that extra data in the inscription wasn't supported, and I had to kind of like hack that around and do my own stuff on there. But for the most part, for normal things, yeah, their library handles all that.
Indexers can...
No, actually, we originally did it at the end. In fact, the documentation that's still out there has the inscription at the end of the script, but because stateful sCrypt contracts use op return and use data that's after the execution part of the script, They moved it to the front, and that works great. We're totally fine with that. Like, that works better for a lot of cases. So.
All right, and any next question from the audience? Anyone else? We have. All right, we have 5 more minutes. Here's the.
Hello, guys. You mentioned recursive ordinals with the example of the randomly generated NFT. One question about your vision of the future for recursive ordinals. You mentioned like building websites entirely with that. So what's the future according to you?
This is where a lot of the cool moving pieces that have been kind of independent for the last year and a half are starting to be able to come together. So, I mean, just for simply, we do have a web server service called OrdFS that just, you can point to a URL that's got an ordinal and it'll give you the file that's inscribed with that. So that's kind of just basis, there's web server. And then Luke mentioned the OpNS thing, which is this domain name registration system. And that still has a little ways to go, but that's kind of, we start getting to the point where you can tie all these things together. And also, I guess this one was fairly early on, with this same web server, there's also some ability to tie into regular domain name services. So I can stand up my shrugger.cloud domain and at the DNS level say, okay, you serve the website off of this web server, and also here is the ordinal origin, the location on chain to use as the homepage for that website. So when people hit that web server, it actually goes out, hits my DNS, and says, oh, this is the page I'm supposed to serve up for that. And that page is actually just an ordinal that is an HTML page that in it has links to JavaScript that are ordinals, that are to images that are ordinals, and links to other ordinals. And so you end up at the point where you're one, like this is my domain, this is my entry point. It's really just an entry point into the world of connected inscribed files on chain. And that's where it gets really, really cool.
So as far as like imagining what this might look like in the future, I picture something like a new type of browser that's that's very native to Bitcoin, that understands what a transaction ID means and knows to go and look for data there and things. I imagine like opening a browser and going to like file new website, and there's a whole bunch of templates in there because people made all these templates that are already on chain, and you just pick what you want that to look like. And it's a WYSIWYG editor type of thing, and you fill it in and you hit save, and the browser's got a wallet built in, so that just makes a transaction in the background and saves it on chain. You didn't have to pay for a web host. All these things. Maybe there's services that you pay for that serve it faster or do edge services or something like that. But yeah, I mean, I really imagine, what's that?
Peer-to-peer networks.
Yeah, that's a whole nother.
Yeah. Oh, I mean, where it gets really, really neat is when it's no longer a world that's served up by the Googles and Amazons and Verizons and whoever else. It is literally your friends and your community are sharing links essentially to transaction IDs, which they hold the transaction. And when you go to view that, you're actually getting it from them, and then now you hold a copy of that as well. And so we don't end up with here's this monolith in the sky of the what's on chain or the gorilla pool where all this stuff lives. It is all a peer-to-peer community. And then what is not at all flushed out yet, but what really gets neat is when we get into, like, if you own these in sCrypt, you own these tokens, you can update metadata about them. You can even reinscribe them to update what they are. And so, yeah, and so by actually holding this thing, you have ownership permissions over it that you can change it. And then when you sell it or transfer it or send it, like, the people aren't just getting what you got, they're getting the entire provenance of what it has ever been. I think, are we? All right.
Okay, this will be our last question. Here we have, and then we will have a short 15-minute break for refreshments next door.
Hey guys, can you hear me? Yeah, cool, good stuff. Thank you ever so much for making it so palatable to kind of figure out what it is, especially for non-technical people. I'm not the technical, I'm not the developer. Just a quick question, are you familiar with a bill of lading, which is a document in shipment?
That is something I am more than willing to let anyone who cares about that stuff deal with it, but no, I have
All right, essentially to the point, so if we would move from like picture of frogs to more enterprise use case, imagine the bill of lading being a document that needs to be updated because it just, pictures the life cycle of a product being shipped from one part of the world to the other. So if you think about it from this perspective, would you be able to describe the transaction journey? Is it like the bill of lading is a one SAT on its own, and then is being spent every single time you're updating the document, or are you like, you know, appending transactions to the SAT that demonstrates the document itself?
Yeah, it is unlimitedly flexible, but absolutely an ordinal can work as a simple, unique identification of any one thing. And as it moves through any real-world process, you can absolutely map out a digital version of that real-world process such that you can provide the tracking back of what has actually happened. So you can model that, but you can also model systems where maybe it's a process and artifacts get added to it, and those artifacts are different ordinals, not the same one. You can model out any kind of process on it, and it's very, very flexible and powerful.
All right. Thank you very much, David Case, Luke Ronaz. One-side ordinals. Thank you. Yeah, so as we're seeing, it was a great opportunity to hear from Darren and Thomas at the beginning, because really what we're talking about is these various different layers and the tools, but that it is important that, you know, just like building a house, you don't want to build the house on sand. You want a firm foundation on what you're building, because you're building it to last. But once you have that firm foundation with the BSV blockchain, you see the unlimited flexibility that is available to you, even through something as simple as TypeScript, which is a coding language that 30 million developers have access to. So with that being said, we're going to wrap the early morning portion of our presentation. We'll have a 15-minute refreshment period next door. For those who will be presenting in the second session today, please jump back to our technical team in the back of the room. We also have a black bag that was located, is back in the back of the room if you are looking for that. And lastly, there are some people that are still waiting for their lanyards, and those are in the refreshment room. Thank you very much, and we'll be back in 15 minutes.
you'll understand kind of the way that script templates work and how we might go about using them within our projects. So you'll understand kind of the way that script templates work and how we might go about using them within our projects. Kind of the way that script templates you'll understand kind of how we might go about using them within our and how we might go about using them. You'll understand kind of the way that script you'll understand kind of how we might go about using them within and how we might go about using them. You'll understand the way that you'll understand and how we might go about using them. You'll understand the way you'll understand how we might go about using them and how we might go about using them. You'll understand the way you'll understand how we might go about using them. As the host, you've done a lot for this space, and thank you for that. Why don't we go to each of the developers who are here with us, and that way we can give an introduction, and then we'll perhaps talk about some of these initial features, and then any questions that we have along the way. Obviously, feel free to jump in for those as well. Let's go to Degan here first, just to give a brief introduction.
Thanks, Ty. Yeah. So what can I say? I've been an app developer in the BSV space for a very long time now. I guess since the beginning of BSV, back in the good old days of Unwriter and so on and so forth. So it's been a long time, and it was actually after that point when I first learned about SPV, and I'm very excited to be building applications with this new TypeScript SDK. It's really great so far, but I want to get to grips with more of the details of the script templating features, for example. So
cool.
Happy to be here.
Yep. Let's go to Damien.
Yeah, hello, I'm from 4chain, and we're the company that is aiming to build some solutions based on the BSV blockchain. And when it comes to me, I'm the leader of the team who is responsible for the SPV wallets tool stack, and that's all.
Cool. Last but not least, let's go to Jake Jones.
Thanks, Ty. I'm Jake. I'm with the BSV Association as well. I work in a variety of different projects. I have a background in software development. I haven't written code professionally for quite a few years now, but I've been working on a number of hobby projects and side projects, and I'm looking forward to understanding this library more. It's going to help me with the stuff I'm doing in my job. I work with Dagan quite a bit now, which is great. And so I need to be able to keep up with him at least somewhat. So looking forward to learning more about this stuff.
All right. And so I think that's going to be the developers here who are going to be following along as we go through this stuff. Let's start with a brief introduction to kind of why a new TypeScript SDK was built. What it comes down to is the need for maintainability and the need to have everything under the kind of management of the BSV Association, make sure that all of the open source components that are relied upon for the operation of the BSV blockchain and the applications built on top of it, make sure those components are well maintained, right? That's essentially the motivation. It's also important that we have a system in place that is interoperable with existing ways of building, while also making sure that it's scalable and open-ended. And there's a lot of different ways in which people can interact with this library. They can create, different systems that plug into it. So really, there were a lot of old libraries out there that had legacy code. Some of it was unmaintained. Some of it was written in JavaScript without typing support. So adding TypeScript increases the stability of the system. We also wanted to unify all of the quality assurance and testing processes across all of those different lower level pieces. so that everything is tested and documented and available, and not depending on a whole bunch of external parties who may not be as aligned as we would like with the goals of the BSV blockchain. And so that was the purpose on building this new library. Yeah, I mean that's basically the high level. Happy to answer questions about kind of the motivations, or if there's any other points people would like to bring up. I think I mean it's clear that based on where we had in the past, where there were 3 or 4 different libraries, a bit of fragmentation, lack of documentation, and things of that nature, it was necessary to kind of consolidate and unify the projects together, and that was the purpose.
I can add some more flavor from personal experience. Really, what we're talking about is the BSV JS library that was kind of ported across from BCH and maintained by MoneyButton. And then, of course, MoneyButton went out of business, or at least closed down that part of the business when they were acquired. No more support for that. Nimble was another option, which was associated with the guys that were involved with run tokens, and that kind of shut down, went in a different direction, and so on and so forth. I think the guys with the BSV WASM solution pretty much moved on to Solana type stuff. So yeah, there was a lot of libraries that existed, and they were just poorly maintained, and nothing we could point to that was really solid. So it's really good to see something that's robust and well maintained.
Yeah, I mean, and to build on that, like there was a lot of technical debt associated with past libraries as well. Like I think the BSV JS library was actually built on Bitcore lib cache, which was coming from the Bitcore origins back a very long time ago. There was obviously BSV2 was another one. There was one called I think it was TS Bitcoin, and so really it was a matter of researching all these libraries, pulling out the best things from them, and then eliminating a lot of the technical debt that was no longer required. There was obviously a lot of stuff where addresses and other things were kind of treated as first-class citizens. Op return, there was templates that were kind of just thrown everywhere for different things. And then there were lots of unnecessary limitations in the library's kind of a script interpreter, which is the way that we verify transactions. And so by going through all of that, aligning with the people who have actually updated those types of systems, for example, making sure everything's aligned with the Genesis upgrade of the BSV network, and then re-implementing some things from the ground up, while also making sure everything was strongly typed within TypeScript. I think there was significant value in doing that, and really that leads into the kind of goals, right? So with this library, we have a few different goals. The first one I want to highlight is zero dependency, meaning that this library only depends on just native types in TypeScript. Every primitive, including elliptic curve, point multiplication, all the big number implementation, and everything from the ground up has been just brought in from external sources, and then I've kind of unified all the ways in which that was documented and tested, and made sure everything has strong types, and then so I brought it in-house, and that way there's no external dependencies on this. Or sorry, the library itself does not depend on any external libraries, and that's useful because it means that the BSV Association is now maintaining an entire stack of tooling from the ground up, with only the language itself as an external dependency, and it allows us to have a lot more control, as well as be dynamic about which components or features of particular external libraries which we previously used are actually necessary, and then get rid of the ones that weren't, allowing to optimize for better performance, as well as make use of new features in modern build environments, such as webpacks, tree shaking, and things like that. So that's why we're zero dependency. And next up, I have essentially unified, right? Like we want to create something that's open-ended enough for everybody to use, while also making sure that it's not bloated, meaning that we want to keep it small, but we want to create open interfaces that are dynamic enough to support a lot of the use cases that people talk about. And so that way they don't have to turn to another library for most of the things, and they can extend the library with only the code that they need for their particular solution. And then, yep, that goes into extensibility and, of course, compatibility, right? So those are the last two that I have listed here. There may be others as well in terms of the project goals. Of course, we want to make sure everything is well tested and stable. We want to make sure that it's well documented and well understood, that there's education in the ecosystem about these various components. That's part of what we're here to do today, is educate people and get everybody up to speed on kind of what is this library and why is it useful. With that out of the way, happy to have anybody jump in if they have other thoughts or questions, and if not, then we can jump into project setup.
I'm just really quickly, Ty. A couple of things that I'm really excited about this library is, number one, the type 42 approach to keys. So we're looking at dealing with keys in a little bit of a new way, but it's getting toward the whole idea of micropayments and microtransactions first, which I think is really important because it's really the competitive advantage of blockchain. It's what a blockchain system can do that no other system can. And I think this is the first time we have a library that's really focused on driving that forward. So I'm really excited about those things.
Absolutely. And that actually brings up into my mind, maybe I should, I might want to actually go through some of the kind of new features of the library in addition to what you could normally do. So maybe we should just talk a little bit about, what can you do with this library that maybe wasn't as easy to do with previous libraries. So we start by delivering with this library a set of sound cryptographic primitives. So things like secure key management for the ecosystem, digital signature computations, and also encryption protocols where that's necessary. So that is where type 42 would come in. Type 42 is a first-class citizen of this library. It's treated as such. There's key derivation operations that you can do. And essentially what that means is that you can have private keys and public keys. And then you can also kind of derive child keys associated with that using these new key derivation schemes that have been implemented. And so that opens up a lot of different possibilities for things like private signatures, more secure ways of encrypting things, and then sending those between parties. And then, of course, deriving necessary information for scripts within script templates and payments that are sent using the transactions in the blockchain, of course. So type 42 is a big part of the library in terms of the key derivation component. And then, yep, it also supports all of our standard cryptographic primitives. So things like, private keys, public keys, symmetric keys with encryption and decryption. Of course, you can do digital signatures. You can do hashes. And then you can do elliptic curve operations. You can go all the way down to the low levels of actually doing like point addition and, there's a Montgomery method thing that you can actually pull out of primitives if you really want to, and you can go all the way down because I've pulled all of that stuff out and exposed it within this library. So that's kind of the first component, is the sound cryptographic primitives. The next component of the library is going to be scripts. So Bitcoin scripts are ways that you can define the constraints under which your Bitcoins can be spent. So we have script level constructs here, things like a network compliant script interpreter that has support for all of the different custom scripts that people can do. Everything that's in the Genesis update of the BSV network is currently supported, and we're going to keep everything extensible long into the future. So
and Ty,
yeah,
just for like a very basic viewer audience, why would you want to define some constraints around Bitcoins being spent?
Well, okay, so someone created a Bitcoin transaction and wanted to pay somebody else, right? And when a transaction is created, it consumes some Bitcoins as input, and it also creates some new Bitcoins as output. And when I create those new Bitcoins, I want to pay somebody, right? Meaning I want to put a constraint on those new Bitcoins that only the person who I paid is able to actually spend them. And as we'll get to later with script templates and how the script interpreter actually works, we'll actually be showing that, and it'll be you'll get some tangible hands-on experience building a script template later on as we go through. But yeah, you want to put constraints on just so that if there was no constraints, anybody in the entire world could just spend all of the Bitcoins, and that would create some slight problems. Okay. The next component is transaction construction signing. So obviously, the library, it's a Bitcoin library, so there's going to be a comprehensive transaction builder, and we'll talk about how that API works. We're going to, basically make sure that everybody can verify transactions and serialize transactions in different formats. That just means, laying them out so that when you send them to the miners or to overlay networks, you can actually do so. In the correct format that those parties may require. You can also exchange your transactions peer to peer. So there's kind of features of the library, such as computing fees on transactions, making sure your change outputs, which are how you kind of send the remainder of your Bitcoins back to yourself, are generated properly. And then, of course, transaction broadcasters and fee models all go into that component as well. So we have transaction broadcast management, of course. So obviously you can send transactions to different places, and then you can get Merkle proofs back. So Merkle proofs are a way to help anchor a transaction back to the blockchain and verify using SPV. And I'm happy at any point throughout this to answer any questions people have about SPV and the simplified payment verification concept. But essentially what it means is that you want to make sure that when you receive a transaction from somebody, that it legitimately spends all of the outputs that it claims to be spending, and that the transactions eventually anchor back to the blockchain. And the way they anchor back is using Merkle proofs. So we implemented that. We implemented some structures and systems for verifying transactions using the simplified payment verification architecture. Library supports is just around actual general messages. So things like the secure exchange of encrypted messages between parties, using type 42, of course, to derive necessary keys, and then message signing as well. So you can create signed and verified messages, both publicly verifiable and then privately verifiable signatures are supported by the library. With that out of the way, there is some documentation, and I would encourage people to go on the library's GitHub repository, and you can then click on the docs folder. And if you do that, you can see a lot of different documentation for each of the various components. There's some API level documentation or code level documentation in the docs folder. And then there's also 3 other folders in there full of documents. So you have low level docs, you have examples, and then you have concepts. So low level docs are going to talk about things like, your what are numbers and points and public and private keys, and AES, symmetric encryption, ECDSA, Diffie-Hellman, hashes, type 42, transaction signatures, and all of that kind of thing, serializing and deserializing of scripts, really low-level stuff. And then the second level up is going to be your examples, and this is going to be like tutorials and things like that. So you can follow along with these different ways of using library, you can, there's an example for getting started in React as well as in Node.js, creating your first simple transaction, verifying using SPV, what's called a beef structure, as we'll get to, which is kind of a way of, essentially setting up all of the information necessary for simplified payment verification. There's an example for, creating a transaction with, lots of inputs and outputs and script templates and things like that. Actually building a custom script template, kind of like what we're going to be doing here today. And then we're going to do, we have message encryption examples, message signing, building a transaction broadcaster to send transactions out to, perhaps a specific miner or custom service, perhaps even just sending it to one of the recipients. We have examples for verifying scripts with the script interpreter. We have examples of using BIP32, and the library does support BIP32. So if you're using a hierarchical deterministic wallet, an HD wallet using BIP32, it does support that. However, the recommendation is to eventually migrate to Type 42 for Bitcoin wallet management. There are examples for creating even a transaction fee model that's custom, integrating with the headers client for SPV verification, and then we demonstrate even things like ECIES encryption. And finally, there are some high-level concepts. So if you want to just learn about Bitcoin from a high level, you can check out other documents as well in the docs folder of the library. So what is beef? As I just mentioned before, that structure for SPV and why is it useful? You can learn about what is a transaction signature? What is Type 42 and how does it enable private signatures? You can learn about things like script templates and what they can be useful for, how transactions are built with different inputs and outputs and kind of the concepts of how that all works. What are the role of kind of header trackers or chain trackers within the SPV, what are the role of chain trackers within the SPV ecosystem? How does transaction fee modeling work? You can read about how are Bitcoin transactions validated by the recipients using the kind of SPV process. You can check out opcodes and how they actually function at a low level within the Bitcoin script conceptually. And then finally, what are hashes and how are they important in Bitcoin in various different ways that they're used? Because Bitcoin does use hashes in a couple different ways. So that's an overview of the library, its major components, and its documentation. And so I think that creates a fairly comprehensive introduction to kind of what is this library, right? We first talked about why do we need a new library, and now we've kind of covered what is this library. And so I hope that has been informative, and I'd be happy to answer any questions. If there are no questions, we can move on to the next section, which is going to be actually running through some project setup and making sure that everybody can follow along here to go ahead with the kind of workshop and practical portion of this kind of session. So are we ready to proceed to that, guys?
We're chomping at the bit.
All right, let's go ahead and PMI BSV/SDK. And so if you do that, then it should tell you that we've added one package. And that's because, of course, the BSV SDK has no external dependencies. And now it should be ready for use. So once you've done that, then we should be able to just say npm run start. And your browser should open. And you should see a little hello simple app. I'm just going to open my JavaScript console here on the right, just out of habit, because I normally do when I'm writing code. And so once everybody is looking at this screen, then we should all be good. So let's just confirm. Is everybody seeing this? Have we been able to follow along?
Yeah.
Yeah.
All right, Jake, you're good.
Yeah, I'm good as well, Ty.
Okay, cool. Just making sure. All right, everybody's here. So now what we're going to do is we can actually open up our little app file, and this is a very, very simple, React piece of code, and this is where we can actually start to interact with the BSV SDK. So let's just do something really simple to start out, right? So like, let's just make a I don't know, a little offline wallet generator or something. It would be super simple to do this. So with the new SDK, we just use the private key, and we'll just build this very simple thing to start out. So we'll just say import private key from BSV SDK, and then we'll go ahead and also have a couple of state variables. So if you know React, we can just set up, let's just say private key and we'll just leave it empty, and then we'll also have one for the address. All right, and then we're just going to, I'll import the use state, of course.
I have Copilot on, and it actually automatically did the address line.
Oh, very cool.
So I don't know if it's following what you're doing right now.
Okay, so now we can just set up a little on-click handler for a button that's just going to say generate. So we'll just say, I don't know, handle generate equals, and then we'll just give it a function. And then we can just say, key equals private key dot from random. And so that is a method on the TypeScript SDK. And if you actually do this, you can see in IntelliSense, if you're using Visual Studio Code.
The landscape of blockchain development is complex, particularly with the core BSV libraries, where scattered forks and alternatives have created a jumble of options to pick from. To tackle this, we've unified them into a new library, ensuring developers have an official SDK which is easy to use, backwards compatible, stable, and performant. In software development, stagnation means falling behind. The BSV library had started to deteriorate with dependency rot and outdated functionality due to the shutdown of the wallet company which maintained it. By thoroughly revising the codebase, we've streamlined it to be more clean, functional and formidable, now supporting an SPV approach to transaction construction and propagation. External dependencies can slow down maintenance and complicate updates. The SDK was built from the ground up with no dependencies, making it lighter, faster, and a comprehensive educational opportunity for developers who want to go deep on the details. This effort was made in order to ensure a stable, well-maintained core library for applications built on BSV now and into the future. Our ambitions extend beyond the JavaScript ecosystem. We are applying the same principles to develop officially maintained libraries for Python and Go. These tools are not just additions, they're part of a cohesive strategy to provide developers with robust, maintained, and standardized resources that meet the demands of scalable blockchain application development. The BSV Library project is more than an update. It's a strategic overhaul to prepare for future challenges by providing a stable foundation for innovation. We're doing the groundwork so developers can focus on creating revolutionary applications. Join us as we pioneer a more efficient, secure, and innovative ecosystem. The BSV Library Project, building the foundation for tomorrow's blockchain applications.
All right. Thank you and welcome back to our second portion of the day's presentation. We just ended our first portion with Luke Rowanaz and with David Case from One Side Ordinals. And also working with David Case, we have Gorilla Pool. Gorilla Pool will be presenting next. And this presentation will be led by Kurt Wooker Jr. As you can see, there's a little bit of what sometimes we like to call coopetition, which is the cooperative efforts towards competition and the value that that brings to an entire ecosystem. I can think of no better person to touch on that than Kurt Wooker Jr. Welcome.
Thank
Hey everybody. Good morning. All right, who here runs a large mining operation or node operator, data services company? And if you don't, who really wants to do that as part of their other business operations? Anybody? All right. There's something that's been talked about for a long time about Bitcoin. And this is maybe the most contentious thing in Bitcoin is who should be the infrastructure of the network. The popular position on this is that, well, everyone needs to run a Bitcoin node on their mom's computer for decentralization. And that's funny to me because we're talking about building a global financial network, and I don't know how many people put in a pitch deck that like, hey, this multi-trillion-dollar network is run by lots of people who have nodes on their mom's computer. Like, that just doesn't strike me as a confidence-endearing concept to pitch to somebody conceptually about their business. So the reason for that is that Bitcoin is severely misunderstood, and that's at every level. That's what is the financial asset, what is the value of the network, what is the value of the infrastructure. All of these things, you can measure them in dollars, which we're all trained to do. Well, not in this country, we measure them in pounds, I guess, but we measure them in units of fiat currency because this is how we think of value. We think about the value of a cup of coffee or a carton of eggs or a gallon of milk and that kind of thing, and that sort of works as a scale for how do we measure everything else. And so we use fiat measuring sticks to explain what the value of a thing is. But that's actually a really weird thing to do because all money is, any money, is measuring the value of data. It's facilitating these gaps in understanding about intrinsic value. So every time you spend money on something, both parties assume the other one is making a fundamentally foolish business deal, right? Think about it. The merchant is saying, like, yes, give me your money. I am trading you this valuable or this less valuable thing for this more valuable thing. I value your dollars or your pounds or your euros, but to you, you're thinking, well, I have children to feed or, cats to feed or whatever it ends up being, and you are saying, cool, I'm getting milk out of this deal, right? So there's this gap in value that we misunderstand that ultimately is a piece of data. It's about the measurement of value and bridging our fundamental misunderstandings of the things that both sides are valuing. And Bitcoin and the data that Bitcoin provides is actually a much better measure of value long term. So what is Bitcoin? This is like a PhD level conversation. I could literally go on this for 2 hours a day for the next 6 months, and I don't think we would actually drill into the real definition or deeply understand what Bitcoin is, and that's because there's so much other predicate information to get into. What is money? What is value? Why do people value the things that they value, et cetera, et cetera? But ultimately, Bitcoin is that facilitator of data, but that data is value, and that value is data. Data is money, and that's really what I want you to take away from this conversation. If Bitcoin is money, and Bitcoin is valuable, and Bitcoin is data, then all these things can be used synonymously for each other if we can get to the point where we all understand that Bitcoin is that layer for that transference of value. So if we can get there, I think the rest of the problems start to solve themselves. Here's the Bitcoin white paper and a monkey. Thank you. So you should start by reading the Bitcoin white paper. I would hope everybody in this room has given it a read. If not, you can read it inside of 15 minutes. It's like 8 pages long if you take away the math and the notes and the references. So read it 3 times before lunch today, and you'll have done a lot better than most people who think they understand Bitcoin, because most people don't read the damn thing. But it's really painfully simple when you read it. It's like, oh, okay. There's a fundamental problem with transferring small pieces of value across the internet. And why haven't we solved this in 15 years? So please read it, or you can just be the monkey. So what is Bitcoin mining? What are we trying to solve here with the infrastructure of the network? So you have to connect to the network in some way. You have to broadcast to the network. Somehow you have to get to Bitcoin, right? Most people do this by downloading a wallet. Then you are able to broadcast to Bitcoin, either directly or indirectly. Then nodes, which are the little computers, or in some cases very big computers, that gather that transaction data and then ultimately compete to put that data on the ledger. That's what they're doing. That's what my company does. It's Gorilla Pool does. Then you also have ASICs, which are looking for a valid hash. It's sort of a semi-separate piece of infrastructure, specialized to do a very particular thing, and that is to simply brute force a list of hashes. And that is simply to show that you are just crazy enough to be trusted to write to this ledger. That's all it is. It's literally the like the fitness instructor and their, you know, washboard abs or whatever, right? Like who would go hang out with a personal trainer who is themselves overweight and hideous, right? Like it's a little bit like, I don't know if I should be trusting you for fitness advice, but what the ASICs do is show that I am at least fit enough to burn a lot of electricity in order to have the right to have my transactions trusted, have my blocks trusted as written by somebody who cares. I care enough about Bitcoin to do this crazy thing for you to trust me, at least to a degree. Then once we reconcile these blocks, we write them to the blockchain, and if accepted, we get paid the subsidy, and we get to take whatever transaction fees are there. Now, it's incumbent upon me as the co-founder of this company to try to make as many transaction fees possible. So I want you to be able to build a business easier and easier and easier every year. So 5 years ago, it was quite difficult to build a Bitcoin app, but as time goes on, I want people to be able to like accidentally start a business on Bitcoin and start generating transactions because they all just funnel to me. So I have every incentive to make you want to build an app because you're making money, and if you make money, I make money. This is kind of like how Comcast or Verizon or Vodafone really, really want you on TikTok and Twitter, and they want you texting, and they want you to be doing commerce over their network. So they try to make it like, here's a free phone, here's 6 months of no whatever. You know, like they keep feeding you things so that you keep filling their network with value. There we go. Here is this is my attempt at being an artist here. Imagine the Bitcoin network as a bunch of semi-poorly connected nodes. So your nodes or your endpoints on the outer ring are people that are hobbyists. They're goofing around. They're, you know, hey, I'm going to spin this thing up in a garage or somewhere else. And then the ones in the center of the network near the B, these are the ones that are like closely connected. Like we have direct API connections to each other, and we really want to share in value. The rest of it, I don't know, I think it's self-explanatory, but it's also what I do on a daily basis. So let's talk a little bit about data. What is the data opportunity here? It's a trillion megabytes of data created globally every day. So this is emails, this is TikToks, this is everybody uploading stuff to YouTube, this is all your favorite influencers putting out video content or whatever else. So it's a lot of stuff. That's not even the financial. So if you include things like Swift and ACH, Visa, MasterCard, we're talking about a tremendous amount of data. And so we talk about being the big data blockchain and taking over payments. And if you were to aggregate global cash, global digital payments, and the internet, we're talking about just absolutely mind-boggling amounts of data that today the biggest companies in the world are involved in propagating and sending out to you so that you can use the internet or use money or whatever else. And so we have a colossal task in front of us as BSV. Like we literally talk about absorbing the global financial system and maybe the whole internet. So I see a number of engineers in here that are working on some of these problems. And first of all, thank you for doing that work. It's crazy work, but I think this is going to be very important work that we're all going to be very proud of someday. Now, Bitcoin was designed to filter out junk data versus good data. If you look at the history of proof of work, the purpose of the very first proof of work was to get rid of email spam. So this is going back like Cynthia Dwark and what's his name, Adam something, CEO of Blockstream, and but guys like Hal Finney, these guys were working on, okay, my email inbox is full of nonsense. How do I make it hard to email me stuff? Have we solved that problem yet? In 20, 25 years of trying to figure out how to get rid of bad email? I don't even get through my email in a day anymore because it's ads and phishing attacks. I can't tell you how many times I have people pretending to be the HR department at my own company asking me to fill out forms to receive stock options. I'm like, why can't anybody build a solution to this? We've literally been talking about it since the early 90s. Bitcoin and proof of work generally was designed to solve these problems. Now, it has solved it with very simple transaction types, but that can be extrapolated out to the entire internet. Like, how do I only see what I want to see on the internet and maintain my privacy and some self-sovereignty? So we're not just focused on being a Bitcoin mining operation. We're focused on actually implementing that to make sure that you are utilizing your time only in a way that is valuable. Now, here's the problem with big block Bitcoin. It's still just a giant chunk of data. If you run a full node client and you look at what's coming in, it is only sorted by time. That's it. So whether I'm sending a cat JPEG or whether I'm sending $1 billion payment between central banks or sending across encrypted information about launch codes or something, those all just are chronological. So literally your cat JPEG traders are next to central bank communications or top secret comms at scale. So how do we fix that problem? How do we fix the filtering problem of these things? Now, I'm a big believer in a two-pronged approach. People talk a lot about overlay networks, which I will talk about in a little bit in this presentation. But there's also indexing and filtering and people only subscribing to the data they need. This is something that has been talked about in the BSV space for a long time. Like, you don't need to validate everybody's transactions. I agree. You don't need to validate anybody's transactions but your own. But how? We, as a mining operation, we have to have that monolithic blockchain data. We run a full node. We don't prune it. We have everything. Everything that happens over BSV, we have to have it. Because we have to have it, why not repurpose it? Why not take practical steps toward filtering for, okay, what are people using? So things like one-sat ordinals from the previous conversation. Okay, let's just make a filter for all one-sat ordinals. But then let's say you, as a company, have a certain subset of one-sat ordinals, bless you, a certain subset of those one-sat ordinals that only your clientele care about. Well, maybe you want to filter out for that. And then you keep running a smaller and smaller index of only the data you need. You subscribe to that through Jungle Bus. That's what we are trying to do. So if you're running an app and saying, God, I really hate paying Amazon every month or DigitalOcean or Hetzner or whoever you're paying in order to run that full node and serve all that data and then run your own index, run your own filtering, be my customer, please. Use Jungle Bus, run a very, very tiny indexer, and only have the, maybe 50 transactions a day that your company actually cares about, and then you can focus on building the rest of your company. So what is Jungle Bus? I kind of just explained it, but in a very basic sense, it is a piece of modified node software that is designed for that filtering and service, and then it's provided via API to you. So you can simply subscribe to an endpoint that just continuously listens to the network. What's up, Frank? And it gives you the data that you need and nothing else. So this is a massive savings to you. Again, I asked at the beginning how many people do or want to run a full node client, and it's expensive, and it sucks, and it breaks down, and it goes out of sync, and then it's like, oh, okay, I had enough RAM 6 months ago, but now I'm getting out of memory crashes, and it's nonsense. I know because we're running this stuff, and we have to keep moving around boxes and refactoring, and it's a full-time job. So if you don't want to be a sysadmin to Bitcoin on top of being your infrastructure to your own company, please, again, talk to me, talk to David and Luke and some of the other people in here who work alongside Gorilla Pool, help maintain these things, and they can help walk you through how this stuff works. So I think of Jungle Bus as an overlay engine. People talk about overlays and indexing as things that are separate from each other. Hi, Ty. I think in San Francisco about a month and a half ago, we actually figured out that these things are semi-integrated and semi-related in a lot of ways. I have always thought of Jungle Bus as the engine for producing the network that matters, the overlay. So the things you care about on top of Bitcoin and nothing else. So overlays are systems that work tangential to or on top of the main network, which you may or may not care about, but they do connect to the network, which you care about tangentially, but only if it all functions right for your business. If none of it works, then you spend a lot of time fussing with Bitcoin, which you shouldn't be doing. You should be working on your business. We also run ARC, which is great. I see a couple ARC people in here, so thank you. This is a really good tool. We're really excited to use it. It's an ingestion engine. So you got to get your stuff into Bitcoin. It has to make its way into Bitcoin blocks, like into the database, and then that data has to come out. And if we can go into Bitcoin and out of Bitcoin in a way that is really easy to understand and really easy to use, all of a sudden Bitcoin becomes a really valuable piece of monetized data technology that everybody can use. So I'm really glad we didn't have to invent ARC. We were big complainers about MAPI and some of these problems a number of years ago. So when ARC came out, we were thrilled with the way that it functions. So thanks to the people that made ARC, we're really happy to run it. So we are unique in that we are a fully integrated company working in this space. Now, Tal is essentially our only competitor. There are other people that mine BSV, but most of the other companies that mine BSV are not doing anything related to data services. They're just a hashing operation. In many cases, they just run a prune node. But Tal is doing a lot of stuff that we are not doing, and we're doing a lot of stuff that Tal is not doing. So I think we're uniquely positioned to remain competitive and cooperative with each other. But we are unique because we're focused on giving everybody really, really simple tools, really simple documentation, and also passing people to some of the other brands, like What's on Chain, for example, that do other data services. Like, we want to have an integrated approach with everybody in the ecosystem, because ultimately we want to see this network bootstrapped in such a way that it is more and more valuable. So here's what we call the banana stack. Kind of a bunch of stuff. These are sort of the things that we give at least some extra support to. And it sort of shows the way that our business is structured and some of the hosting that we provide to other people. So this is another thing that I wanted to talk about. So we host a lot of the one-sat ordinals infrastructure because it's just better for the system if those tokens can be instantly available because they are physically close to our nodes. So they use Jungle Bus, but instead of using Jungle Bus over the internet, in many cases, the stuff is actually in the same box. And just allows greater speed so that token trades can be more rapid and that kind of thing. But if you have a company that is just like, hey, we're doing really rapid data and latency is a problem for us, like, talk to us about hosting in our infrastructure. We have really good ops people that would love to integrate, not just closely, but like, really closely with our company and yours. So please don't be afraid to talk to me about that. And these are some of these things. Like Bitcoin schema is like a series of protocols for how to build like a secondary internet over Bitcoin. So it's just logic that if you follow it, you're automatically part of the Bitcoin schema ecosystem, which includes one-sat ordinals, magic attribute protocol, the Sigma identity protocol, and some of these other things. So please get in touch. I sometimes get confused for the CEO. The CEO of Gorilla Pool is actually a literal gorilla. I just work for him. But I make most of the valuable business deals, so feel free to talk to me. He gets a little grumpy if he's hungry. Brett, how much time do I have left? 5 or 10 more minutes. Does anybody have questions? I will answer questions about literally anything, so don't be shy. If I got 5 or 10 more minutes, if anybody's interested in your business also getting involved in hashing, we got one. It's my opinion that everybody that owns a business entity in the space should have at least some exposure to ASIC mining. And we're also the only public mining pool in BSV. So if you've ever wanted to just earn some virgin coins out of the block rewards, A, you would be making the network objectively safer. You're contributing to the network. And B, we don't just give you random coins. We literally give you coins out of the block rewards. So you get virgin mined BSV, which I think will be more valuable over time, but I'm kind of a numismatic nerd when it comes to that kind of stuff. But also, there's a lot of business reasons to do that. I would recommend you talk to your CPA about stuff like taking bonus depreciation and things like that. It's a good way to offset taxes and other things to be involved in computing for the network you're using. And it also makes Gorilla Pool bigger, better, happier, and all of that. So don't be afraid to hash with us, too. Question?
Yeah, thank you. I was curious, do you have a specific use case? You don't have to, name a customer, but like, how do they actually use your service in terms of de-indexer overlay? So.
Who in here uses Jungle Bus for things? A few people. Okay, three people. So one set ordinals is probably the most frequently used thing. So what that's doing, the way that ordinals works is it's essentially keeping a secondary index of the order that every single sat in existence has ever used. Now that's, I don't know if people understand in computer science how big of a problem sorting is, but it's a massive problem that really hasn't been solved other than just more horsepower. And so we provide that horsepower, and then we allow people to, instead of running that whole index, just simply hit the API and say, is this token valid or not? Rather than having to solve the back to Genesis problem and some of these things yourself, we give a guarantee, and you can just hit that endpoint very simply. So that's probably the most used thing. But anybody that has artwork or documents or any of this, this MetaNet concept of that sort of data, all of that kind of stuff can be served over Jungle Bus. But I had dinner with somebody last night that was talking about their need for streaming Merkle proofs and TX IDs out of the mempool, or Merkle proofs after their mind, but before their mind, like, is this a valid TX ID? And we explained basically how to use it. That, well, you can make a subscription for any kind of tag. So if you want to tag your TX IDs with some kind of reference, then you can keep a filter, and then anytime a TX ID matches the use case that you have, you can simply stream that. Because what this person was talking about doing is, I'm trying to get my full node synced, and I'm having trouble with this, blah, 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 blah. And I'm like, hey, by the way, you should be a Jungle Bus customer because you can just subscribe to those things, and you don't have to deal with any of that infrastructural cost or going out of sync or whatever else. So, yep, no problem. Sir? Really, with every situation, it's bespoke, because a lot of people have their own internal token protocols and all these other things. So for us, we kind of don't care. We're agnostic to what your own desires are for how you want to program in Bitcoin. It can be. So yeah, so we have a couple of clients that will like SSL into their own box, but it's on our box. And so you have access to your stuff. You can program however you want, and then but we give you direct like Ethernet access or whatever to our node or to Jungle Bus or whatever it ends up being. But these are always bespoke because literally everybody has their own ideas about how to program in Bitcoin, and that's totally cool. But it makes it a little bit like there's not a 1 + 1 = 2. It's always like, okay, explain to me your stack and how this works, and then we'll build it out for you.
All right, thank you.
Hi, I've got a question along with that.
Yep.
So as everyone's building out on the network, and you mentioned Bitcoin schema, and then you're mentioning tags, where you were talking about too, but can we have some organization? I know like Bitcoin schema is like very limited right now, or so when you're talking about Jungle Bus and the tags, does that mean can these tags be reused, or is like someone creates a tag for themselves, but other people can see it on the network, right? Or could we have some organization on that? Or is it just for Gorilla, or is it just for Jungle Bus only?
No, so I mean, a lot of things are tagged, like ORD is a good example. So there's an ORD tag in ordinal-based transactions, and that can be something that just sits in the op return, for example, which can be pruned at a later date or whatever if we don't want to keep that information forever. But there's lots of things that are tagged that we aren't necessarily filtering for. So if you wanted to make like a STAS token, for example, has its own, like there are things about STAS tokens that are obvious that it's a STAS token, and therefore we can filter for them and serve STAS token or a subset of STAS token data if it's desired. So there's a lot of things out there that nobody's using, but they could be using and use Jungle Bus as that provider. So it's up to you.
Awesome, thanks, Kurt.
Yep.
Next, we have a question from Jeff. And then we will have Rafa present.
I can tell this is going to be a hard question.
It's not going to be too hard, no. Okay, so you run an indexing service, but we are at 1 million transactions per second with Terranode. That's only going to get higher. Indexing becomes an NP hard problem at scale. What's your plan?
So at a certain scale, it's simply to throw more hardware at it. We are actually already on the 3rd iteration of Jungle Bus from the time it was created. And a lot of that is, like we moved from Cassandra database to TyKV, and now we're looking at things like Minio and some of these other database types. So ultimately it's more hardware horsepower, and then it's also software optimization anywhere where it's possible. But one of the things that I think is really key is that Terranode was built by people and built with the same logic as the people working on Jungle Bus. So the people related to those things were trying to solve kind of the same fundamental problems with Bitcoin. And so the notion of like breaking out these things and modularizing them in Terranode so that individual processes can be accelerated when necessary, Jungle Bus kind of works in the same way. And so, you know, it's just going to be work at some point where we're going to have to refactor and whatever else. But, you know, we'll talk about the same thing. I heard somebody ask the other day, like, well, what about when we're at 1 billion transactions a second? It's like, you know, like when people first built cars, they did like 15 miles an hour and people still like bounced out of them because we hadn't figured out suspension yet. But like, hey, if you want the car to do 50, you need to figure out more engineering problems. And so, the exciting thing is that if we get to 1 million transactions a second, I think we'll have the money to invest in better and better engineers and all of that. So, or we'll fail as a business. And another one, Ty. And feel free to Shepherd's cane me off stage when we need to.
If you accidentally forget to let me know about one of my transactions, which is like tagged or whatever, right?
Mm-hmm.
Like, how would I know that you forgot to let me know about something that was made it into a block? But
yep. So we've talked about this problem with sCrypt. The sCrypt team has talked to us about this and said, well, hey, is there like how do we know? Well, it's one of those things where Bitcoin makes things exponentially better, but Bitcoin never 100% solves everything, including like transaction finality, for example. Like you get to 99.99999% valid, but technically, like you could rewrite the whole BTC blockchain from day one if you had the motivation and enough power and everything else, right? So there is that probability that decreases and decreases and decreases over time, but never becomes a promise, basically. But what we are talking about doing is getting exponentially better than existing systems when it comes to, is this real data? Is this valid data? Is my payment really mine? Like we're trying to get as close to perfection as possible, and that's really the best we can do. Now, in a practical situation, if you're the kind of company that, hey, all of my customers' data is critical, mission critical data, well, then we can talk about doing something special to make sure that cryptographically everything matches. Like we can talk about Merkle proof validation on every single thing. Now that itself slows things down. We start having conversations that are Maxwellian and talking about everybody running their full node again. But it really depends on the nature of the project. Like if it really matters that much, yeah, there are solutions to that. But right now with people trading ordinal token, like I think Degan said, where's my Pixel Fox, right? And it's like, no one's gonna lose World War III because your Pixel Fox took an extra 3 minutes to index, but there are things that do matter like that, and it's a different problem to solve. But that's the kind of thing like we can set a totally separate business model with you. We can have a separate contract. We can talk about ways to fix that. But it's a business solution, not necessarily a tech one.
All right, and we have a final question here for Kurt. As well, I want to draw attention if somebody lost their cell phone by the coffee machine. It is currently over there at the host stand, and someone is calling it incessantly. So, just come up and pick it up. But here is the final question, and then we will have Rafa from HandCash.
Thanks. Yeah, just curious, along the lines to that question, since it seems like you depend on tags to filter transactions, you mentioned spam earlier. How do you fight tag spamming, for example, somebody including transactions, including tags in transactions that are not related to?
It's a good question. Right now, we're not doing anything like that, but there's a number of proposals that have floated around for a long time. Like what was Powco stuff, like Daniel Krawitz has talked about some of these kind of things, or basically what if we did proof of work at a different level? This is kind of what POW20 tokens are doing, saying like, okay, instead of just having the first guy there mint 80% of the supply, what if everybody has to submit proof of work in order to participate and all of these kind of things? And so there's some really easy ways to mitigate, or at least make it a little more costly to do that kind of thing. So that can just be something that gets added if it becomes a problem. But I see that as an indicator that we've already been successful if it's worth somebody's time to try to spam, try to attack things. Like if you're under cybersecurity attack, like you're a threat to somebody, and so that means there's probably money there to also solve that problem. But it's something we've talked about internally, but as of yet, it's like, just not top of the heap, but it is something that we've considered, and I think user side proof of work, like small proof of work, but just something is one good way to do that. And then there's a couple other ones we've talked about internally that I will not be sharing yet today. But thank you. Yep, thanks everybody.
All right. And before we move into our next presentation, I just want to really quick acknowledge two of my friends here in the audience, Jean-Bray and Baby Bear, two professional Hearthstone players. And we have our next presentation coming from Rafa from HandCash. And we're going to be learning about how data ownership relates to the massive, massive gaming market. Rafa, welcome.
Good afternoon. As a game developer, as an entrepreneur, what is the most important question that you want to answer? What is it? Is it, am I picking the right framework? Am I choosing the right architecture? Am I even hiring the right people? There's one that is even more critical than all of this. And that question is, am I building the right product? Because if you're not building the right product, none of this really matters. So I'm Rafa Jimenez. I'm the CTO of HandCash, a company who has helped developers, entrepreneurs, just like you, to answer this question multiple times. So we help you to find the answer to this question in a very effective way, because you can run a business plan, you can do some market analysis, you can do many things, but there's only one way of actually answering this question, and it's by building the product. You come up with an idea, you build the product, you give it to some users, and then you get some feedback in exchange. And this is how you actually validate if you're building the right product. But this is why you don't want to spend resources. You don't want to take like 6 months of funding, and you don't want to put all of that passion and enthusiasm into building the wrong thing. So from HandCash, we can help you with 3 main resources. The first resource, or surprise, surprise, is you want users. It can be very frustrating trying to get your first users, your early adopters. So this is the first thing that we can provide for you. We have very enthusiastic users with wallets, with balances that can get connected to your game directly so that you can fire payments on demand. So from the user perspective, this process, it's quite simple, right? The user gets redirected, it's in your platform. At some point, it gets redirected to HandCash. HandCash will prompt the user with some dialogue where it would be asked to provide certain permissions for your game. And right after that, the user eventually will accept the permissions and get redirected back to your game, ready for the action. So at that point, you will get an authentication token. Just please remember about this, because I'm going to ask you after. You will get an authentication token that you can use to programmatically create any kinds of things. So the second resource that we provide for you is game items. Of course, I mean, it's a game. But you don't want just to sell your game items directly from you, which obviously this is very obvious. There's better ways of getting there. You can create referral programs. You want to make sure that your game is getting distributed from even physical stores, any kind of partnership. So you want to do this, but also you want it to be simple. So the second thing that also you want for your game items is you would like them to be tradable, not only from you to the user, but also from one user to another. And that will let your game create a secondary market. So the very good thing about this is we already created this market for you so that you don't have to, but you can still get the royalties every time there's a transaction in this secondary market. And then the third piece, which obviously is very obvious, is you need payments. But you don't want any kind of payments. You want an engaging experience. You don't want to interrupt the user when the payment is going to occur, like to prompt it. It's just really weird. Just imagine going to a casino and every time you want to bet, they interrupt you and no, sir, like you have to enter here your credit card details and do this and do that. Obviously, that's very stupid. But unfortunately, that's still the experience that you could find in most places, with PayPal, with even Apple Pay, Google Pay, and there's still most of the Web3 wallets are actually creating that experience where in the middle of the, that hot moment of engagement, you will get interrupted to confirm your payments. So you want to avoid that. You want to maximize engagement. Also, you want a payment system that does not limit your possibilities for monetizing. You want low fees. You want payments that go in many different directions, not just from the user to your pocket. They can also go from user to many other users while you're getting paid for it. So you don't want to limit your creativity in that sense. And also, another limitation that you don't want is when it comes to the amount of the payment. You can go as low as you want, going to even 1 cent, 5 cents, a few dollars, whatever suits your business model. So all of that is actually possible. The thing here is all of this, it works on the blockchain. It works using the BSV blockchain. And let's be honest, having BSV as the token to use it as money is really not ideal. Because first thing is, of course, the price fluctuation. So as you're collecting your earnings, you're going to be a bit exposed. But it's also the understanding from the user perspective of they're not familiar with this new token. They are familiar to dollars, euros, the currencies that they know. So starting this summer, we're going to start supporting stablecoins, a USD dollar-based stablecoin, introducing to you money. So money is a USD-based stablecoin, so one token equals $1 US dollar. And this is brought by our partners that I would like to thank, Raw Wallet and Tokenize, for making it possible on the BSV blockchain. So you will be able to collect your billions, or billions, I mean, trillions, I mean. You will be able to collect them using a dollar equivalent. Oh, sorry, I've not been updating the slides. Right. So the third and most important resource that you need is time to market. So you don't want your new fancy payment solution to take 6 months or even 6 GUIs to get implemented. So I would like to show you how this can look more like 6 days. Now this is the moment. Do you remember the authentication token that we said before? Anyone was listening? Nice. So now we get this authentication token that represents the user permission to access to their wallet and to their game items. And just in a piece of code like this, short, we can initialize the account, and from there we can have access to it. This is what the piece of code could look like to trigger a payment with multiple participants. Again, we plug the authentication token, define the payment terms, amount, destination, and that's it. This is what the code snippet to get the user inventory, to have access to the game items that they have available under their account. This is what it would look like, another 5 lines of code. This is what the code required to transfer a game item would look like. Again, just another few lines of code. This is a bit longer, but don't get scared. This is the code to create a new game item. You can specify the appearance, images, attributes, all kind of attributes, and of course the user who will be receiving this game item. So with all this tool set, we've been able to help companies to find the answer to the right question in a very efficient time. And this is the life of startups. So fortunately, some of them don't really make it. We help them to get the answer. It doesn't mean the answer is you're always doing a great job. We just, that's really on you. Sometimes the answer is you're not building the right product, sorry. But for the ones who really create the right product, there's a point where they come to us and they say, this is great. I've been building the right product. Your tools, they've been very helpful. But now I was able to grow my product. I have a community. I'm acquiring my own users. And I don't want to be relying on you. I don't want you to be bringing me the users. So we understand at some point, this process of connecting the wallet can get a bit difficult, and it's not ideal. So this is why I like to also introduce that we are extending our offering, and we are offering now something that is called Wallet as a Service. So it's the same benefits that we discussed before. It includes everything for managing game items, for managing payments. Everything is there. But also, you are able to create accounts as you require them, get access to your users' accounts so that they don't have to be connecting their wallet any longer. And also, that's still keeping the same benefits. Our accounts, they are backed by multi-party computation, threshold signatures, everything is non-custodial, but it's still as convenient as it was for you. So building new games is very exciting. You have the chance to create a new community, you can make money, you can entertain people. However, it can get very, very difficult. The struggle trying to find your first early adopters, the frustration trying to integrate a payment solution that is very hard, and also the waste of time trying to integrate very complicated APIs. So the next time that you really want to build a new product, do you really want to hit the same walls again? Hopefully there's a better answer out there for you. So handcash.io. Thank you for your time.
All right. So do we have any questions here for Rafa, or open it up if anyone wanted to ask Rafa anything? Otherwise, we will have our lunch session. So we have a question right here.
Thanks, Brett, and thanks for the presentation, So the question is, what's the denomination of the stable coins, like can we transfer 1 cent of that coin? Can we do 1,000th of a cent? Is it?
Right. You can actually do a bit less than 1 cent.
Okay.
Can go to 1/10 of a cent.
1/10 of a cent. Okay.
But in the context of the companies we've been working with, there's no one really going that low.
It doesn't make sense because how would you, 1/10 of a cent, you can't get that back in US dollars if you wanted it, right?
Yeah, I get in that context,
Yeah,
it's also a bit hard. But I'm just, giving a bit of clarity on the stable coin. We are partnering with Raw Wallet.
Yeah.
Anyone is free to do the same thing. Mm-hmm. You don't have to do it through us. We are just offering this for game developers to try to make it more convenient. But if anyone out here, we have now USD-based stable coins coming to BSV. Anyone is free to use them. And if that use case works for you, then, free to use it.
Do that. Awesome. Thanks.
All right. Do we have any other questions here for Rafa? Otherwise, we have our lunch session planned. So we'll have an hour break, during which we'll have lunch in our refreshment room, and we'll see you back here in an hour. Thank you very much.
Thank you. Thank you, man.
Yeah, great job, as always.
This over here?
Yeah, okay? That's perfect.
Of blockchain development
Clone
is complex,
this repository,
particularly with the core BSV
and
library,
once you
where
do,
scattered forks and alternatives
you
have
can go
created
ahead
a
and
jumble
change
of
directories
options to
into
pick
it,
from.
and then just
To
go
tackle
ahead
this,
and
we've
open
unified
up
them
a
into
Visual
a new
Studio
library,
Code.
ensuring developers have an official
And
SDK,
once you
which
have
is
that,
easy to use, backwards compatible, stable,
once you have
and
that set
performant.
up, then
In software development,
you'll be able
stagnation
to
means falling behind. The BSV
install the new
library had
SDK.
started to
So
deteriorate with
this
dependency rot
is
and
a
outdated functionality
simple
due to the
React
shutdown of the wallet company
project
which maintained
that
it.
we're going to be using as
By thoroughly
our
revising
starting
the code
place
base,
for this.
we've streamlined
And
it
I'm
to be
just
more
going to go
clean,
ahead
functional,
and
formidable, now supporting an
install
SVV
the
approach to
new.
transaction
Firstly, I'm going to say
construction and
npm high, which is going to install all of the
External dependencies can slow down
dependencies
maintenance
for
and
this
complicate updates.
project. And then
The
I'm going to say
SDK was built from the ground
npm
up with no
BSV
dependencies, making it lighter, faster,
SDK.
and a comprehensive educational opportunity for developers who want
And
to
so
go
if you do
deep on the
that, then it
details.
should tell you
This effort
that
was made in
we've
order to
added
ensure
one
a
package,
stable,
and that's because, of
well-maintained
course, the
core library
BSV
for
SDK
applications
has
built
no
on BSV
external
now
dependencies.
and into the future.
And now it
Our
should be ready
ambitions
for
extend
use.
beyond the
So
JavaScript
once you've done
ecosystem.
that,
We are
then we
applying
should
the
be able to
same
just say
principles to
npm
develop officially maintained
run
libraries for Python
start,
and Go.
and your browser
These
should
tools are not just
open,
additions,
and
they're
you
part
should
of a
see
cohesive
a
strategy to
little
provide
hello
developers
simple
with
app.
robust,
I'm just going to
maintained,
open my
and standardized resources that meet the
JavaScript
demands
console
of
here on the right,
scalable
just out of
blockchain
habit, because I
application
normally do
development.
when I'm writing code.
The BSV library project is more than an
And so
update.
once everybody
It's a
is looking
strategic
at this
overhaul to
screen,
prepare for future
then we
challenges
should all be
by
good.
providing a
So let's
stable
just confirm,
foundation for
is
innovation.
everybody
We're doing the
seeing this?
groundwork so
We've been able
developers
to
can
follow along?
focus on creating
Yeah.
revolutionary applications. Join us as we pioneer
All right.
a more
Jake,
efficient,
you're good?
secure, and innovative ecosystem.
Yep, yeah, I'm good as well, Tom.
The
Okay,
BSV
cool. Just
library
making sure.
project,
All right,
building the
everybody's here.
foundation for
So
tomorrow's
now what we're going
blockchain
to do
applications.
is we can actually open up our little app file, and this is a very, very simple, React piece of code. And this is where we can actually start to interact with the BSV SDK. So let's just do something really simple to start out, right? So like, let's just make a, I don't know, a little offline wallet generator or something. It would be super simple to do this. So with the new SDK, we just use the private key, and we'll just build this very simple thing to start out. So we'll just say import private key from BSV SDK. And then we'll go ahead and also have a couple of state variables. So if you know React, we can just set up, let's just say private key and we'll just leave it empty. And then we'll also have one for the address. All right, and then we're just going to, I'll import the use state, of course.
I have Copilot on, and it actually automatically did the address line.
Oh, very cool.
So I don't know if it's following what you're doing right now.
Okay, so now we can just set up a little on-click handler for a button that's just going to say generate. So we'll just say, I don't know, handle generate equals, and then we'll just give it a function. And then we can just say, key equals private key dot from random. And so that is a method on the TypeScript SDK. And if you actually do this, you can see in IntelliSense, if you're using Visual Studio Code, that it tells you exactly what is going on. It generates a private key randomly and takes no parameters. So now we have this key, and we can actually do a couple things, right? So we can get a whiff out of it. So we can say const whiff equals key dot to whiff. And if you do this once again, you can see that it's going to convert the private key to a wallet import format string. And then now we can just, I don't know, set private key to the whiff value. And then of course we also want a public key and an address. So we'll just say public key equals key dot to wait, do I have to address? Oh, I guess I do have to address.
I added that.
Very cool. Right. So little convenience functions do help. And, we want to make sure that developers have the best experience possible. So I guess we don't need to make a public key. We can just say const address equals this. And then we can say, set address to address. So in theory, we have this handle generate function now that should populate our state variables with a new little, simple thing, right? So we can just change our little h1 to, I don't know, we can say, I don't know, private key generator.
If you're planning to display that address, I would toString it. Otherwise, you're going to get some
of course
object injected into that.
Right. Yeah. So an address. Wait.
Right.
No, it's already a string.
Oh, it's already a string. Okay, great. Of course, there is no concept of an address in the new.
We don't actually have a structure for the address.
I'm thinking that the old libraries had an address struct, but not anymore, right?
Right. Okay, so we've got this, and then I'll just kind of replace this with the actual, so we'll just say our address, and then we're going to display the address out. And of course, we'll do the same with our private key, and then we'll throw in a little generator, a generate button. And now if we just add a button on click, handle generate, and we'll just put generate in it, right? Saving this code and looking at our web browser, we now have you just hit this generate button, and if everything works properly, then you've got a little private key generator. So by doing this, you can generate as many Bitcoin private keys and addresses as you would like in React using the new TypeScript SDK. So that's our first very, very simple demonstration here. And kind of how do you set this up? How do you do this in React? And then generating a simple private key with the new SDK. Of course, you could add some fancy style sheets and everything like that, but we'll leave that for another time.
We are but simple devs.
We are. Okay, so that is the first little thing here. I'll move back to my document here and consult that. Happy to answer any questions, or if anybody was not able to follow along, just let me know. Okay, so let's just go ahead and look here. Okay, so we want to build and broadcast a transaction using the library next, right? And of course, that's going to mean we need some funds and everything like that. but we'll just assume that we have some funds in a particular UTXO, and in the model of Bitcoin where we're using SPV, we expect people to kind of keep track of the UTXOs, whether they're doing so in a wallet or whether they rely on some service for it. So we'll assume a couple of things when we are creating and broadcasting a transaction. We're going to assume that we know where the money is, and I'm just going to annotate this here, right? See, assumptions. We know which UTXO we want to spend, and it's a P2PKH UTXO, and we have the private key. Right. So those are our three assumptions. And with that in mind, we can go ahead with what it would look like to, to actually spend this. And we have the UTXO. You can get this information from what's on chain if you want to do that. We would encourage people to retain it when people send them transactions in the future. But I'm also going to make another assumption, just as I thought of it here, which is that we actually know we have the source transaction. Where the UTXO came from, right? Because if you have that source transaction, then you can actually, it makes it a little bit easier. So with that, what we would be able to do is essentially, and we have an example of this, so I can just kind of grab the code from that, and then we can, we can just explain what's going on and run it. So if I go to the examples, there's one called building a transaction, creating a simple transaction, and there's just some code here. So what I'm going to do is copy this code from the example, and looks like we're importing a few things as well, but I'm just going to copy this part. And I'm going to go back into React here. And so I'm going to make this a little bit more generic, right? But this one, I guess we'll just change the title to transaction builder or something. And then, I'll just say handle. I'm just going to make this more generic for now. And I'll change this to Go, right? So, so we just have a little transaction builder, and you click the button, and we're going to rely on the console this time just to see what's going on. So we'll just replace this handle generate with handle click. Right, and now I'll just go ahead and paste this code that I copied from that example into here. And then what I want to do is go through this with everybody, make sure we understand what's going on. This handle click uses asynchronous stuff, so I'm going to go ahead and make this async. And I'm going to update the imports. I think we need. I'll just copy the import line from this one, right? So this would be how you can essentially create a transaction, and so you've got a private key, and we assume we know what that private key is. So I'm just going to use a random key, but in reality, what you would do is you would actually need to provide your actual private key where you had your money stored that you're going to spend in this new transaction. And then we're going to make a change private key, which is going to be different, right? You don't want to use addresses, or you don't want to use scripts the same for your changes where you got your coins from. That would not be good for security and privacy. And then we can just pick an address. So this is just a string, right? Which is who you want to pay, right? All right, so we now have this handler function that when we click it, this stuff is going to run. And we're going to create a new transaction. So the SDK, when you create a new transaction, you can just use this, and it gives you some options here. You can pass these in, but they're all optional, right? You could actually pass in all of the stuff needed to create your transaction, which is a version, array of inputs, array of outputs, and lock time, but none of that is required if you're going to use the builder. The first thing we're going to want to do is actually provide the source transaction, which is where you got your coins from. And we made that as one of our assumptions, right? Is that actually we had that transaction, so that when someone paid us these coins, which we're now going to spend, we kept that around. And that's what you do in SPV to scale properly, is you actually keep that stuff around, either in your wallet or somewhere else. And that way, you know, when you go to spend your money, you just have it, or you can get it from some service. But here we're just going to I mean, we can get a transaction hex, but essentially, I mean, we have two options here, guys. We could either do this, like we could actually create this type of transaction and then broadcast it, have it go on chain, or we could just run through more of a conceptual example of what's going on here, you know, based on I guess what this code looks like and what would be going on were we to actually, you know, put in a source transaction and whatnot. I wonder if you guys have any thoughts on whether we should try to create some transactions using actual funds, or whether we should go through and just kind of talk about the concepts.
From my perspective, it would be awesome to see it working, and not just speak theoretically. So.
Okay.
Yeah.
I can create a transaction that. How can I do that? I'm just trying to think logistically how we're going to set that up. We want to create a few.
But basically, you need a source transaction with an output that pays to the key that you have. Right. Oh no, you don't have a set key. You're just using random keys, right?
But I could create a set key, of course.
How might you create a set key? Well, I suppose that's what we just did, right?
We just did that, isn't it? Right. Okay, so why don't I?
Has anyone still got the app in that state that can just generate a key just right now? I actually saved it, come to think of it. So
I have it.
You got it?
Yeah, I can.
If someone wants to just like create
chat,
maybe we can fund a couple of like we could generate 4 keys or something, and then fund them with like 10,000 sats or something.
Yeah, I'll fund some keys. I'll fund this key. Because then we can just do private key from WIF, right?
From WIF, yeah. And then we'll just need the source transaction, which is hex, and then we'll need the WIF key. And so I'll generate my change key such that let's see, I'll be able to back that up pretty easily.
That's the address for Davian's key.
So if we all kind of create a document like this, we'll have our private key, our change key, we'll have an address that we're paying to. and then the source transaction and V out.
I have one source transaction.
Do this on mainnet, right?
Yes.
And then Ty, I saw that the word Babbage there has only one B in the middle. I didn't know if that was...
Thank
Nice.
you.
Mm-hmm.
Well spotted.
Is that async? I don't think it is. No, it's not. Okay, have we generated, are we continuing to generate more source TX? I'm just writing some code right now to generate a few of them, because what I'd like to do is get everybody to a state where we have each, because what we did in the recording is we created those assumptions in the document. And so if we get everybody to a state where they have a key that has money in it, a change key, an address who they'd like to pay, and then a source transaction, then once everybody has that, then we can kind of just follow. We can actually make it happen. Okay, so the address is going to be.
Okay, so 10,000 sats into this key. And that's basically all. Okay, so if I click that button, then it should do that. Oops. What's going on? Oh, I see. That's why all the type information was missing. Right, that would do it. There we go. So now if I click this button, in theory, source transaction. Okay. Oh. Okay, so we want to get everybody to a state where we have, two private keys, one that has money in it, one that we're going to send our change to, and then we want to have everybody want to pay to an address. And I'm going to look at that code again, but I believe that's basically the requirement. So we'll then kind of bring that to fruition, and then once that's the case, yeah, this is source output index. We have the private key. Should be able to sign and send. Fee, sign, and this is required for broadcast. But what we'll do instead of broadcasting is I think we will dump it to hex and then go to what's on chain and actually just broadcast it using the utility they have for that. Might be the easiest because we'll have a hex string. Okay, what's everyone's status? Do we have these created? Should I send people different revisions of this that have different keys so that we can each follow along?
I am set. I think I have a source transaction. I've been following along to have a template for a transaction based on that so far. I'm at calculating fees in terms of the process.
Okay. So I'll just go ahead and copy this code then, and we'll just go ahead and proceed. So I'm only going to copy this much of the code this time. I'll get rid of So because I'm working off chain, I should just be able to actually. Oh. All right, I'm confident that if I were to actually do this, that it would work, and therefore we can kind of resume the commentary for the purpose of the recording when you guys are ready.
I think I'm ready this side. Maybe not. I think I just killed my app. Compiled successfully. I got a blank page.
Yeah, I had a couple of those. I forgot to remove the address and private key from the bottom after I deleted the state variable, so it was giving me undefined. I look in the console and then it told me.
Can I use a transaction type in React use state, like an object, basically?
Yeah, you can if you use a little. If you're using TypeScript, if you use a little. Yeah, you can put it in the React state. It would also be possible to. Oh, I see. It would also be possible to just convert it to a string and then.
Oh, thanks.
But either case.
Thank you. That's exactly. So I wanted to hold it in state, but of course it kills the app because it tries to display something that's an object. Yeah.
Right.
Okay, got it. Okay, so I have something that you press one button and it will generate a transaction. You press another button and it attempts to broadcast it.
Okay.
So I don't know if it'll work. And it gives no feedback. So I should probably add feedback of some sort. I need some help on the what does the broadcast interface return? A broadcast response or failure. Okay.
It returns broadcast response or broadcast failure. The yeah, it'd probably be best to use that. I'm just thinking we would need to use an actual API key for Arc, would we not? Or is it required to?
You can, if you hit https://arc.tile.com, I think it does not check for API keys at this stage. They've got a special deployment that's they're sort of, yeah, they wanted to test the throughput, so they removed the tappy stuff that checks for the API key.
Okay. So I can then actually just make use of this entire, okay, because I was operating under the assumption that I would want to actually, right, but I'll just.
You should be able to just, yeah, I don't know if this is right, but what I've written so far is transaction.broadcast and then new arc with just the URL, because it doesn't have a token. That would be it doesn't have an API key. So I think that should do it.
I don't know if that's an optional, let's see.
Yeah, let's find out. So broadcast response. Oh, this is awesome. You can just click through and it'll take you to, okay, so broadcast response is an object that has status, TXID, and message.
Yep.
So let's say if the status is success, the string success, then everything's fine. So I'll check that. And so res status equals success. Or if it doesn't say success, broadcast failed.
All right, I think I'm about in the same state as you, Dagan. I should be able to now click the button and see what will happen.
Okay.
So I'll just do that, and here we go. Oh, of course. I have to import Arc. We'll try it one more time.
Dear, I have a problem now. I think that might have worked, and then my app crashed, so I don't know what the TXID was. Oh. Yeah.
I'm looking at the network tab of the browser. I see that RawTX in the payload. I saw Core's cross-origin issue. I don't know if they have access control allow origin for browser-based TX. It may be easier if we want to just dump out the hex and then go to what's on chain and just use that as a. Although it'd be cool to demonstrate in this tutorial as well the broadcast features of the library.
Yes.
We did actually create a broadcaster client for what's on chain, I think, as part of one of the tutorials. So we could, although I don't know if that's actually part of the library currently.
Oh, that's a good point. Yeah, I don't know if WOC has been added. I think I know what you mean.
We could simply just grab the hex and drop it into, this screen here, right? I'm not sure if the ARC side, I'm seeing cross-origin errors. Let me look at the headers.
We can set up the webpack to make a proxy to the from the local host to the TARS API. So
it's true. So that would be Webpack. Yeah, that would, because what is this? How do you?
It is proxy in the dev server, I think.
Proxy, and then what? So slash broadcast. See, know what the URL is. Let me grab it here. And that proxy would ignore.
Hold on. Just remove arc from the end, and add arc in place of API. So arc.tal.com, no slash.
Arc.tal.com, and that's it.
That's it.
And that
Right
works.
now you should. But that I'm glad that came up because Damien, I didn't know you could set proxies like that. That's cool.
Yeah.
You're missing a comma after the proxy object, but oh well, I guess it's not needed now.
Yeah.
Hopefully it's not needed.
We'll give this a try. It's a much cleaner URL too. So if that's in case, or if that's in fact going to work, then. I see a TXID. I think we did it.
Nice.
Cool.
Right. So, yep, that's essentially how that works. What I can do at this point, and let me know what you think is best. You think is best, Brett. We can either move on to questions about this particular thing. I can go through and give a little bit more commentary about what this code is doing, and then we can do questions, or we can just move on to the next piece. Of course, balancing things like time, what we want to get through, and kind of what people want to do.
Yeah, I think let's open it up to any questions or comments about what we just walked through, and hear feedback.
And so we got this code here, and essentially, what we did in this little example is, we made some assumptions. We had a transaction that was where we got our money from. We then had a private key. We had somebody that we wanted to pay, and we used the library's script templating features to just kind of create a simple pay to public key hash payment. Also unlock the previous UTXO, and then add our change output as well as the amount we wanted to pay to the other person. We computed the fee using the default fee computation, and then we signed all of the templates. We then got a response back from the transaction broadcaster and updated that within our little user interface here. That's a brief overview of the code, and happy to answer any questions about it. I think it's fairly straightforward, and there's a written example of this, of course, as well, you can follow along with.
It's very cool. I think the most useful thing is the setting change true, and just being able to, like, if you're just playing around in developing a locking script or something, setting it change true so that you don't have to bother figuring out all of the what the change is reduced by,
right,
and just being able to sort of whatever transaction you create, if you have an output that is the same locking script, then you can literally just update the source raw TX. Like, so I don't know, I wasn't watching the screen closely enough to tell if you're printing the new transaction as hex to the screen. Is that what you were doing?
I did print the TX ID. I didn't print the hex, but I can actually go grab the hex because it's right
in your console somewhere or something.
It's going to be
in the head.
In the oh gosh,
the broadcast.
It's
in the broadcast.
Yeah, it's right. It's right here, actually. Right. Perfect. There it is. So that's the hex.
So you can just copy paste that into your as your new source transaction, and now you have a new source transaction which you can just spend again and create a new one.
Yeah, yeah, that makes sense. So there's that, and then of course, now that I have this this TX ID, what I can do is copy it, and actually we can check to see that it computed the fee properly, right? If I go to just like what's on chain or something like that, I can give this TX ID. And I can see that we had our input, which was the amount that I was previously consuming. And then we had the amount that I wanted to pay to that address. And then, of course, the change. And there was only, I believe, 3 Satoshis as a fee. Is that correct? It looks like. I could be wrong here. Maybe it's
3
Satoshis. Times
That's
10
right.
to
Negative 8 is right. 3 sats.
Yeah, so it computed the fee using the default fee model. So for 3 Satoshis, I was able to do a 1 in, 2 out transaction, and that is essentially the first little goal that we had here in this session, is to kind of demonstrate that. So here we already kind of introduced the concept of what is a script template. And so we're using this pay to public key hash script template for this. And that's what we're using to actually, sign and spend the pay to public key hash UTXOs that we're dealing with, as well as to create the new ones. So a script template is kind of an open-ended way to work with different types of scripts in BSV, and of course, each script template can be configured with different parameters depending on the type of script that you're working with. In the example of pay to public key hash, we configure the unlock portion of the script template with a private key, which is then used to spend or sign the previous UTXO as it's being spent. And then we also have the lock portion, which is how you actually set up, where you want your new P2PKH or pay to public key hash UTXO to be going. And for those that aren't aware, just pay to public key hash, it's basically like a Bitcoin address in layman's terms, right? Yep, that's essentially the concept of what is a script template. And that's really moving into the next section here, which is script templates and their utility. Each script template has a lock and an unlock portion to it, and those are used for creating locking and unlocking scripts respectively, for creating and then subsequently spending various UTXOs. We've implemented various different script templates within the TypeScript SDK. I'll go ahead and pull up the interface, which is what must every script template have, and then we can review that and answer any of your questions about the concept of script templates before moving into a more involved example of actually implementing a script template in practice. Let's go to scripts. So I'm just going to pull up the library source code only to show the interface here, which is just so we can understand what a script template must have in it. So I'm just going to go to script template.ts here. This interface defines the structure for script templates used in Bitcoin transactions, right? It provides methods for creating a locking script, creating an unlocking script, and estimating the length of an unlocking script. So you can see here that it can take any parameters in the lock method, and then it can return either a locking script or a promise for a locking script. And that's basically the first thing that every script template must have. Second thing is, in the unlock one, you can pass any parameters, and then it's going to return an object with two functions. And that's going to be a sign function, which given the transaction and the current input will return a promise for an unlocking script. And the estimate length, which given those same two parameters, the transaction and the input index, will return a number of bytes, which represent the length of the estimated length of the unlocking script in that context.
Ty, can you just give a really quick refresher of what a promise is?
Yes, in JavaScript, essentially a promise is a way to say that you're going to call back to the caller later and finish with a return value. It allows for asynchronous programming because JavaScript is essentially a single-threaded language, but you can kind of defer execution, and for things like dealing with network requests, things like dealing with long-running tasks, you might use a promise to kind of just defer the execution. And the reason why I'm talking about promises in this context is because, suppose I wanted to make an HTTP request out to some API as part of my script template in order to learn what should be the correct locking script given particular parameters. Or perhaps I wanted to do some key derivation operations using something like the Babbage Metadata client or other systems that do asynchronous calling out to different other systems. The purpose of the promise here is just to make sure that those long-running tasks can be kind of set up, and then when they're done, then the promise is essentially a promise for the return value at some future time. The library will know to then expect that future return value to happen once the promise has been resolved, and that way we can be more dynamic about the way that script templates generate both locking and unlocking scripts.
Awesome, thank you.
Right. So does anybody want to wager a guess as to why I had to add the estimate length method for unlocking scripts specifically?
Estimate length because unlocking scripts often have signatures in them, and we don't know how long a signature is going to be to the byte, at least, because it could be, 72 or 73 or something like that.
Right.
Was that the main reason?
mainly, and then some scripts could be different lengths, and it's useful to know how long we estimate the unlocking script to be sometimes before we sign, and the reason why is for certain fee models and fee estimation. So we may not know exactly how
Like
many
a hash puzzle, for example, so it could have a big data blob for all we know that hashes down to something that will unlock, right?
Right, and so by providing that big blob in the unlocking script, the length could be very long, and that could have a big impact on if we're using, for example, fee per kilo, satoshis per kilobyte as our fee model for the transaction. We need to let that fee model have access to that information, potentially even before the inputs are signed. And the reason why we have to do that before the inputs are signed is, of course, because, change outputs amounts will depend on the approximate fee, or the fee that we're end up going to pay. And so we should fix those change amounts based on the information that comes from the length of the unlocking script prior to actually signing, right? Because if we signed first and didn't know the length yet, then we may have to change the change outputs afterwards, which would, of course, break the signatures if we're using, sChash single, sChash all, any of that stuff. So that's why in your script template, for example, pay to public key hash, and we'll look at the code for that one next as a practical example of a very common script template. The length is always I always estimate it to be like 106. And I generally recommend people to estimate just slightly high. So like if it could be 104, 5, or 6, it's like, okay, well, I'm just going to put 106 because I don't want to estimate too low. And it doesn't have a large impact at all on fee modeling, but each fee model can do what they want with that information. And it really just depends on which templates you're using. But if I go into the templates folder and look at pay to public key hash, this is one of the common templates used. And so to define a script template in the library, and we'll go through this one, and then we'll actually create our own in just a second here. You implement the interface, of course, so we can see export default class implements the script template interface. Therefore, we have the lock function, which, as we know, given some parameters, will produce a locking script. And so, as you can see here, we see dup hash 160, and then our data, and then equal verify checksig, which is the locking script for pay to public key hash. And so we're just using some essentially just we're computing we're coercing some data into the right format so that it can make its way into this script, and then that's our locking portion of the pay to public key hash script template. This one supports passing in a string, which is just a Bitcoin address, or you can pass in the public key hash bytes as an array of numbers. Any questions about the pay to public key hash locking template before we move on?
No.
All right. Moving on to how we unlock with this template, right? You pass in a private key, and then I added some other things. So when you unlock a pay to public key hash thing, you might want to determine some scoping on the signature that you're making, right? Maybe you're signing something for all of your outputs, or none or single. Of course, can anyone else pay after you? And then you can optionally provide your source satoshis and source locking script just so that you can avoid providing your entire source transaction if you don't happen to have the entire thing available. So, right, we can see that it's going to return the sign and estimate length functions in an object. So that way, when the library, when the library actually is going to, deal with this information later, the library itself will invoke the sign or estimate length functions as it needs to, and you yourself don't need to do that. You'll just pass this, you'll call unlock and set that as your script template. But sign function, it takes the current transaction we're signing and the input index of the UTXO, which we are going to spend. It sets up the sig hash flags for the signature based on the parameters which I have stipulated. And then it goes ahead and it takes out the current input. It computes other inputs by just taking the current input out. And that way we know how to set up our kind of transaction signature. It's going to figure out the source TXID and the source Satoshis and locking script, which are all elements necessary to create the transaction signature pre-image, which is what you actually sign when you unlock a Bitcoin UTXO with op checksig. So of course we pass that information in the source TXID output index, the source Satoshis, the transaction version, other inputs, the index of the current input, and then we take out some information about the current input. We pass in which outputs are here, the sequence number, the subscript, the lock time, and the signature scope on the pre-image, which we're going to then create. We take that pre-image, of course, we hash the pre-image before we sign it, and the signature process computes the other hash, so it's a double hash in total. And then we create a new transaction signature from our raw signature, which came from the private key. We hydrate back in our RNS values and, of course, our signature scope, which you can't forget, because then you have a really bad day because you don't know why your check sigs are failing if you don't put your signature scope in. I learned that one the hard way. That wasn't very fun. And then, you basically just compute the checksig format of that signature so that you can drop it in as a script element. You compute the public key from the private key, and then you just create your unlocking script, right? So now you unlock this UTXO by providing the signature and the public key on the stack in your unlocking script, and you return that out, and then you're done. That's how the unlocking of a pay to public key hash UTXO works in Bitcoin, and that's how you can define such with this script templating system. Any questions about the unlocking process and kind of the steps involved here? As we compute the signature pre-image, of course, and we compute the signature over the double hash of the pre-image, and then set up our unlocking script.
No questions for me.
All right. Any questions about why it's 106? The comment makes it pretty clear here, right? So estimate length, it just returns how long your unlocking script is probably going to be, or thereabouts. That's why it's an estimation. So P to PKH, it's usually pretty close around there. All right, I've gone through the theoretical walkthrough of script templating stuff, and if everybody's ready, I will move on to a practical example where we actually implement our own script template.
Yeah, let's do it. And what type of example will you be leading us through?
Let's go back to the document here, and essentially it's going to be a much simpler one, talking about how scripts can work at a low level. The idea that I had was just to do number multiplication. So it's like, okay, well, I don't know. We could say that the locking script is going to say, what times 7 equals 42, and then the unlocking script is going to say, well, 6 times 7 equals 42, right? And then if it provides the correct answer, then the UTXO is unlocked and our transaction is allowed to succeed.
Sure. And just so that I can understand this at a high level, this actually allows for distributed computing, because now you can reward the participants of the network who can provide useful solutions to these problems, and these problems could theoretically be arbitrarily complex.
Exactly. This is a very, 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 very simple thing that, anybody can compute. So there's no reason to, put money on the line as a bounty for computing this type of thing. But someone could take this and make it much more complex. And that's the purpose of the script templating engine. The purpose of this exercise is going to be so that we each get some practical experience implementing a very simple template, which you could then iterate on and make more complex. You could even integrate things like sCrypt. And you could kind of understand how that stuff's supposed to work.
Yes, and also at a high level, you have the capability of permitting certain participants of the network to be involved with the solving of some of your complex functions, which to unlock these as part of the unlocking script, but also you can hide other components of what they're solving, so that maybe if you have some secret sauce, for example, that that you want to keep as proprietary knowledge for your business logic, but you want to offload some of the computation component, this allows you to do that in a very simple way. Is that correct?
That's correct. You would just need to implement your requirements, either using sCrypt and then creating a locking script, unlocking script template pair based on that. You could use high level language, or you could implement it directly in Bitcoin script. The templating system provides the framework by which you can make it easy for people who want to use your script templates to do so within their transactions without needing to understand all of the low level and intricate details of how to write low level Bitcoin script opcodes and make all of that stuff work.
Awesome. Yeah, I'm very fascinated by this. Thank you.
All right, let's go ahead and get started with implementing a little number multiplication template here. And so in order to do that, what I'm going to do is switch back to the React project that we had open from before, and I'm just going to make a new file. So in this new file, I'm just going to call it multiplication template.js. And the only reason why I'm using JS here is because my current Webpack environment, I do not believe supports TypeScript, but we can still make use of the library's TypeScript features even within JavaScript projects. I'm just going to import the script template, as well as, I think I'll need op, which is opcodes, from the BSV SDK. Export default class right. So we're exporting a class that implements this script template interface. And of course, okay, I didn't realize that we can't use that in this context. What is the best solution here? I'm going to see if this can work. It wouldn't be too hard to modify our Webpack config to use TypeScript. It's just that I wasn't, let's see, can I now, it's going to say